Hello. As shown in the figure, a particle is moving with a constant speed pi meter per second. Considering its motion from A to B, magnitude of the average velocity is, and you can see the diagram, it goes from position A with a speed v to position B with the same speed v. Velocity is different because direction is different, but speed is same. And angle of the radii when it was at A and at B is 120 degree. Options are 2 root 3 pi, root 3, 1.5 root 3 in meter per second SI unit. So here first of all, recollect formula for average velocity. Average velocity is displacement upon time. So can we calculate time here? Since this is moving with uniform speed, since the body is moving with uniform speed, we can say this is uniform circular motion. So the motion will be taking same time for every one complete rotation. So we can calculate that time period, and we can get the time period by using angular velocity formula. So we know angular velocity omega is equal to 2 pi by capital T, correct? So 2 pi by capital T, 2 pi as it is, capital T as it is, omega, I am writing omega as V upon R, because omega is angular velocity, what we have is pi meter per second, that is linear velocity. So omega replaced as V by R. So velocity value is given in the question. Velocity value is pi divided by R equal to 2 pi by T. So pi and pi cancel. We have answer for time period. Time period is equal to 2 times R. So we have the time period value. Okay. Now we will solve for time required to go from A to B. So notice that A to B is 120 degree, which is 1/3 of the entire circle. To complete one full circle, it will take time 2R. For the time that we need to study, that is A to B, body will need only 1/3 of the time because speed is constant. If angle that it has to cover is 1/3, then the time also it will be 1/3. So total time is 2 by R divided by 3. This is the time to go from A to B. Now we also need to know what is the displacement, not distance, displacement. So to get displacement, we have to join the shortest, we have to draw the shortest path, straight line path between A and B. So this is the displacement vector. Now how will I get that displacement vector? So to get that displacement vector, we can use geometry. We can take help of cosine rule of geometry to get the answer for AB length, which is displacement, length of chord AB. Or you can use displacement is also equal to change in position. So if I consider this vector, let me use a different color. If I use this vector as initial position of the point A or the body, and this is final position. So this is our initial vector and this is our final vector. Now if I calculate displacement vector, I can get displacement vector. Displacement will be final position minus initial position. Okay. So if I use final position minus initial position, then I will get the displacement, that is AB line, and magnitude of the displacement vector we will use in the calculation. So to get the magnitude of these two vectors, notice that both the vectors are equal in magnitude. Both of them are radius. Okay. Here we have used R for the radius, capital R, in the calculation of time period. So both these vectors have same magnitude. Let me write here magnitude of R1 vector, magnitude of R2 vector, both of them are equal to capital R, that is radius of the circle. So notice that I am subtracting two vectors which have equal magnitude. I am subtracting two vectors which have equal magnitude. Now if magnitude is same and you're going to subtract two vectors, then we can use a direct shortcut formula that we get from vectors. So 2 into R, that is magnitude of the any of the vector, into sine of theta divided by 2, where theta stands for angle between the two vectors. Okay, so we can use this formula for subtraction of two vectors, magnitude of the subtraction of two vectors which have same magnitude. Both the vectors have same magnitude but different angle. Angle between them is theta. Then subtraction, okay, magnitude of the subtraction of two vectors will be given by 2r sine theta by 2. If it was magnitude of the addition of two vectors, that means the resultant of two vectors, then the formula becomes 2r cos of theta by 2. Okay, so here we need difference, subtraction. So we will use this formula 2r sine of theta by 2. We can put the value of theta. Theta here is 120 degree. So 120 degree divided by 2, that is sine 60. So that gives us sine 60 value is root 3 by 2. So 2 and 2 cancel. Okay, so we have the displacement magnitude as well. That is equal to root 3 times r. And now we can go for calculation of average velocity. Visible? Yes, visible. Average velocity. So average velocity is displacement upon time. Magnitude of the displacement here. I'm going for magnitude of the velocity as well. So displacement magnitude divided by time. So what is displacement here? It is root 3 into r divided by time. Time is 2r by 3. So this is displacement and this is time. Now we can see we can cancel few things, which is r and r. Rest of the numbers we can rearrange and we are done. So if I rearrange this 3 will move up, 3 root 3 upon 2, which is 1.5 into root 3 meter per second. Visible? Visible. Okay, so correct answer will be option D. We can get this magnitude of displacement by using simple geometry, by doing a construction also, or you can use cosine rule as well. If you have to use cosine rule here, I will write here if it is visible. The third side AB of that triangle will be equal to r initial square, or if I give the name of center to be O, then it will be under the root OA square plus OB square minus 2OA OB cos of theta. So if we had to solve this, okay, I hope it is visible to you. So if you have to solve this by cosine rule, we can directly use cosine rule as well. Both OB and OA are equal to R. Okay, we'll give you the same final answer. Okay, thank you. Hello. On a temperature scale X, the boiling point of water is 65 degree X. Freezing point is minus 15 degree X. Assume that the X scale is linear scale and equivalent temperature corresponding to minus 95 degree X on the Fahrenheit scale would be. So here the question is about the concept of temperature measurement and different scales that we use for temperature measurement. So we have seen various scales: degree Celsius, degree Fahrenheit, Kelvin. So here we have to deal with an hypothetical scale which is degree X. Now for all the linear scales, we can write one common fact, that is reading in that scale minus lower fixed point upon upper fixed point reading minus lower fixed point upon upper fixed point minus lower fixed point. Now what is lower fixed point stands for? Freezing point of water. Lower fixed point stands for freezing point of the water and upper fixed point stands for the boiling point of the water. Okay, lower fixed point is the number that we give to temperature at which the water freezes. That temperature is called as lower fixed point of that scale. The temperature at which water boils, whatever number is given to the temperature at that point, is called as upper fixed point. So lower fixed point is freezing point of water, upper fixed point is boiling point of the water. So if I write down this for, let's say, degree Celsius scale, just to make you understand the concept. So reading in degree Celsius minus in degree Celsius, freezing point is given as 0 degree Celsius. Freezing point is called as 0 degree, and upper fixed limit, that is boiling point, that is 100 degree Celsius minus lower fixed point. Now this ratio will be equal for all the linear scales. So here I have written 4 degree Celsius scale, not for the purpose of question, but just to make you understand the concept. Now in the question, we need a conversion between 2 different scales. One is Fahrenheit. So if I write down the similar conversion for Fahrenheit, so degree Fahrenheit minus, in Fahrenheit, lower fixed point, that means number associated with the freezing point is 32 degree Fahrenheit, divided by upper fixed point is 212 degree Fahrenheit. So melting point, boiling point of water is assigned as 212, freezing point of water is assigned as 32. So reading minus lower fixed point upon upper fixed point minus lower fixed point equal to, now let's write down same thing but for the scale mentioned in the question. Okay, now in this particular question we have to solve for degree x, which is a new scale. So reading in degree x minus, in the question read carefully, they have given us the references for this new scale. On the temperature scale x, boiling point is assigned as 65 degree x. So boiling point means this is upper fixed point, and freezing point is assigned as minus 50 degree x. So freezing point means lower fixed point. This is lower fixed point. So minus 15, that is number assigned to freezing point, divided by upper fixed point is 65 minus lower fixed point is minus 15. Okay, we have to take it along with the sign, and now we have to get conversion between these two. So I will simplify only that part first. So reading in degree Fahrenheit minus 32 upon 180 is equal to, here it will be x plus 15 divided by 65 minus plus 15. Okay, now what to do? We have to get value of Fahrenheit. If in degree x it is given as 95, so Fahrenheit value we have to calculate minus 32 equal to 180 shifted to this side. I will put the value of x. The reading that is now measured in x is minus 95. Minus sign is here, do not forget that. Minus 95. So x value is minus 95 degree plus 15 divided by, this will be 80. Okay, cool. Now this 0 and this 0 cancel. We can divide by 2. This will become 9. This will become 4. So final answer in degree Fahrenheit will be 32 will be shifted. So 32 will become positive here. And then this answer will be 9 into this answer will be how much? This answer will be 80. Okay, minus 80 divided by 4. So we can simplify this. This will become minus 20. Okay, so minus 20 into 9. So answer in degree Fahrenheit will be equal to 32 minus 180. Okay, so that will give us the answer minus 148 degree Fahrenheit. Okay, minus 148 degree Fahrenheit. So correct answer here will be option A. Understood? So first we write the conversion factor for linear scales of temperature, and then we, just for the understanding, we did for degree Celsius. That was not part of the question. The main calculation is this. Writing this equation is where your calculation will start, and then put lower fixed point upon upper fixed point minus lower fixed point. There you put value of reading in degree x, so minus 95. Substitute that and then simplify. Okay, so this is our final answer, minus 148 degree Fahrenheit. That means option A. Thank you. Hello. Two identical particles, each of mass m, go around a circle of radius a under action of their mutual gravitational attraction. The angular speed of each particle will be, and then the answers are in terms of square root of g m. G is universal gravitational constant, m is mass of those m, which is mass of particles. Both of them have identical same mass, and a is radius. So the coefficient in the denominator is different, 8, 4, 2 or 1. So first let's visualize how this will look. Okay, let's first visualize how this will look. So you can see this now. There are two particles identical. I have colored them differently so that it will be visible for you, but they are identical particles, same to same. Now if you go as per the question's description that these two particles are doing circular motion due to their own gravitational pull. So first let me show the line joining them. So you can see this is the line joining them. Okay, and now if they are moving because of their gravitational attraction, how it will look? One particle will be pulled by the other particle. Same, that particle will be pulled by this particle. Can you see? If I show you to in top view, this is how it will be. And now they are moving in a circular path, so it will look like this. Okay, let me make this in little 3D. Now you can see the green arrows are representing the force of attraction that is between the two part masses, and that force is responsible for circular motion. Okay, let's go back to calculation. Now here is one mass, here is another mass. Their center of mass will be at the midpoint because both the masses are identical. So center of mass will be at the midpoint, and the radius of the circular path is r. Okay, they move in a circular in a circular path, and the radius of that circular path is given as a. So this is radius a. This is radius a. Okay, and now they will move like this along this circular path as we saw in the animation. Correct? Now our goal is to find out what is going to be their angular velocity. Now see, in this case question becomes easier because both the masses are identical. Otherwise we'll have to find out their center of mass, and about the center of mass we will calculate their angular velocity, linear velocity, whatever it is. But here it's a system of two identical masses, so center of mass will be at their midpoint. There is no external force acting on them. Whatever force is there, it will be their mutual force. External force is not there. Center of mass will remain at rest. These two particles will move, and their velocity we can show. One of the particle, let's say, going in this direction, other particle going in this direction, like this. So here the gravitational force of attraction between the two masses will play the role of centripetal force, and centripetal force formula is mr omega square, and gravitational force between the two masses will be g m1 m2 upon r square. Now in the Newton's law of gravitation, g stands for universal gravitational constant. F, m and m are the two masses, both of them are identical, divided by r square. Now r in the formula stands for distance between the two point masses. So here the distance between them will be diameter, 2 times a square, is equal to m, radius is also a, into omega square. So we can simplify this. M and m cancel. So gm remains in the numerator. This will be 2 square, 4, then a square and one more a from the other side, a cube, is equal to omega square. Okay. Now to get the final answer of omega, we have to take the square root on both sides. So in the numerator we have g into small m. In the denominator we have 4 into a cube. Okay, so this is our final answer. So key idea here is the gravitational force between the two masses plays the role of centripetal force. Centripetal force is not any other special force. The force which is acting on a particle along the plane of circular motion along the radius towards the center. Net force along the radius towards the center. That is called as centripetal force. In different circular motion, different forces will play the role of centripetal force. So here gravitational force between the masses was playing the role of centripetal force. And option is B. Thank you. Hello. A bullet of mass 0.1 kg moving horizontally with a speed of 400 meter per second hits a wooden block of mass 3.9 kg with on a horizontal rough surface. Bullet gets embedded into the block and block moves 20 meter before coming to rest. So this is the subsequent motion of the block. Bullet gets embedded into the block and then the block moves 20 meter before coming to rest. Coefficient of friction between the block and the surface is, and G value we have to take as 10 meter per second square, and values of coefficient of frictions are there in the option. Now here first have to visualize what is happening. Always in mechanics, when you need to draw a diagram or a FBD, first you close your eyes and visualize, read question and close your eyes, visualize how things are happening. So first you will make diagram here, then you will make diagram on the paper. So this is, let's say, the surface, rough surface, on which there is a block is of mass 3.9 kg, okay, and there is a bullet is of mass 0.1 kg, but bullet has velocity, okay. This velocity of the bullet is equal to how much? 400 meter per second. Now this is the diagram just before the collision. Now what will happen just after the collision? How it will look just after the collision? So just after the collision, this is the wooden block and bullet is now embedded. It gets fixed, okay, it gets trapped in the wooden block, and now both of them will move together like one single body. So this is their final velocity, V final. Now mass as a whole system will be different now. 3.9 is purely mass of block, and in this we have 0.1 kg of bullet. So total mass of the system is now 4 meter per second. So here we can use principle of conservation of linear momentum. Horizontally there is no force acting on them, so horizontally momentum will be conserved. So we can use total momentum initial is equal to total momentum final. So initially momentum of the entire system means bullet and block together. So mass of bullet, momentum formula is mass into velocity, correct. So mass is 0.1 kg for bullet, right, and its velocity is 400. And the block is of mass 3.9, but its velocity is 0, is equal to, after collision, this is just before the collision, this is just before the collision, and this is just after the collision. So just after the collision, their combined mass will be 4 kg. Here I have made mistake in the unit. Total mass will be 4 kg, right? So 4 into combined velocity V final. So this second term is completely gone, 0. This will be 40 divided by 4 equal to V final. 40 divided by 4. So that gives us V final equal to 10 meter per second. So 10 meter per second is the combined velocity of the two blocks, block and bullet. Now with this velocity, they continue their motion. With this velocity, and the entire motion continues. So we know the initial velocity for the subsequent motion, the motion that is going to take place after the hit. For this we know their initial velocity. For this subsequent motion, initial velocity will be 10. And now during this motion, friction is opposing them, so velocity will reduce, and they will reach somewhere where the velocity will be 0. Okay. Now which force is acting on them, which will oppose them? It is the friction force. So if I draw FBD of this combined system somewhere in the middle, somewhere in the journey, then in that FBD, which all forces will be there? There will be weight force acting vertically downward, mg. There will be normal reaction R, and the direction of motion towards right side. So kinetic friction will be towards left side. Okay. So now motion is happening horizontally. Vertically forces are balanced. So normal reaction vertically upward is equal to mg downward. Mass value is how much? Mass value is 4 kg. Combined mass is 4 kg. G value 10. So this is the normal reaction value 40 Newton. Now I can solve for retardation that block is experiencing. So the block's motion is towards right hand side. So while applying laws of motion, we take the right hand side positive. We take the right hand side positive. So if body is going towards right hand side forces will be positive. Here the frictional force is towards left hand side, so that friction force will be negative. So net force is equal to mass into acceleration, but for x direction. So horizontal there is only one force, which is friction, acting opposite to the direction of motion, hence negative, is equal to mass 4 kilo into acceleration a. Now this frictional force value is kinetic friction, that is mu into normal direction, is equal to 4a. Now we can simplify this. That will be mu value we have to calculate. Normal direction value is 40, right, divided by 4 equal to a. Okay, putting normal direction calculation from here. Okay, you can see here normal direction. So we can simplify this now. We got acceleration value equal to 10 into mu with a minus sign. 10 into mu with a minus sign. Minus 10 mu. So this is the acceleration value. Now we have to solve for what is the coefficient of friction. That means if I get acceleration, I will get coefficient of friction. Oh ho ho ho. Wait a minute. Okay. Now that we have acceleration value, what we have to solve for is only acceleration. Acceleration value is minus 10 into mu. We have to solve for mu value. So we can use this acceleration value in the kinematics of the motion. In kinematics, what we will use, we know the stopping distance, how much distance it take to stop the vehicle. We know that. We will calculate acceleration from that formula. So let me complete calculation here. So I will use third kinematic equation. V square minus u square upon 2s is equal to a. Okay, visible? Visible. V square minus u square upon 2s is equal to a. So final velocity will be 0 for the combined block and bullet. Initial velocity is 10. Square this upon 2 into displacement is how much? Displacement is 20. Okay, and acceleration value is minus 10 into mu. Okay, so this minus and minus cancel. One of the 10 cancel from both the sides. Then this 0 and this 0 cancel. Mu is equal to 1 by 4. 2 into 4. So 1 by 4 means mu value is 0.25. Okay, so this is your value 0.25. And do we have option like this? Yeah, we do have option, and that is option A. Understood? So we used multiple concepts of mechanics here. First we used principle of conservation of momentum to get the final common velocity. Then we draw FBD of the combined system to find out what is the deceleration. There we went with FBD, kinetic friction. We got the acceleration as minus 10 mu. Then we used kinematic, because acceleration is constant, mu value constant, 10 constant. So acceleration is constant. So we can use kinematic equation. So in the question they have given us that after hitting, the block bullet system takes 20 meters to stop. So that is going to be the displacement of the block bullet system. So I will use third kinematic equation. See, time to stop is not given and time to stop is not asked also. So that's why I will avoid other two kinematic equations, because those equations needs time. Third one doesn't need time. Time is neither asked nor given. So I'm selecting third equation. V square minus u square upon 2s is equal to a. Now put acceleration value from the previous calculation. Vu values we know from the question's description. Simplify. Mu value is 0.25. Okay. Option A is correct. Thank you. Hello. A gas mixture consists of 2 moles of oxygen and 4 moles of neon at temperature T, neglecting all vibration modes, the total internal energy of the system will be. So answers are in terms of R and T. R is universal gas constant, T is temperature in Kelvin, absolute temperature, and number of moles for each of the gas is given. Now we can do two things. We can calculate energy of oxygen and energy of neon and then add. That is one way to go about it. Or we can calculate specific capacity at constant volume for the mixture of these two gases, both, and then calculate what is the internal energy. So if I go with internal energy of just oxygen, then internal energy will be equal to NCV T. Okay, we are not calculating difference here, we are calculating energy, so not delta T, just T. So NCV T, that is equal to internal energy. So U is equal to NCV T. Now what is CV? CV is specific capacity at constant volume. Now for that we have the formula, which is F into R by 2. Now what does F stands for? F stands for degree of freedom. R is universal gas constant. Now this degree of freedom, students, this will be different for different kinds of gases. So it is different for a monatomic, different for a diatomic, different for a diatomic non-rigid, different for triatomic, linear and non-linear, polyatomic, vibrations are there, not there. So this degree of freedom will change as per the type of the material, type of the gas. So here, if I solve for oxygen, then there are 2 moles of oxygen, and oxygen is a diatomic molecule, and we have to neglect all modes of vibration. That means there is no vibration. Okay, so the degree of freedom, if I solve this for oxygen, then degree of freedom for oxygen will be 3 translational degree of freedom and 2 rotational degree of freedom, 5 degree of freedom. Okay, 5 degree of freedom is for oxygen gas. So we can use this in the above formula. Energy for oxygen will be equal to number of moles of oxygen 2, degree of freedom 5 into R by 2, temperature T. So this and this cancel. That will be 5 R T. Now we can do the same thing for neon as well. So now we are solving for neon, and for neon what we can do, same formula, energy, internal energy of neon will be equal to N into CV delta T, but CV value, you know, it is F into R by 2 into T. What will be number of moles for neon, 4 number of moles, and degree of freedom for neon, inert gas. So there are only 3 degrees of freedom, that is 3 translational degree of freedom. So here we can write down degree of freedom is 3 into R by 2 into T. Okay, there's no need to write down this again. We can just put the value of degree of freedom. So degree of freedom will be 3. So energy will be equal to number of moles 4, energy 3 R by 2, which is F into R by 2. F is degree of freedom. For neon it will be 3. Now simplify this, and this will be cancelled. Okay, so if we cancel this, we are getting 3 into 2, 6 R T. Now this is for neon. Now notice we have 2 answers. This is energy for oxygen and this is energy for neon. We want energy of the entire mixture. So energy of the entire mixture will be addition of these 2. So that is 5 RT plus 6 RT. That gives us 11 RT. Okay, so this is the shortest way to solve the problem. 11 RT means option C will be correct. Now what is the other method to solve the problem? The other method is to calculate CV of the entire mixture. This is the other method, not the shortest one, but you should know this. So how will you solve for CV of the mixture? It will be N1 CV1 plus N2 CV2 divided by N1 plus N2. By using this formula, what we can do? We can calculate the value of CV of the entire mixture, and then to get the internal energy, total number of moles will be 2 plus 4, 6 into CV of mixture, okay, multiplied by T. So this is the formula that we will use. Now CV of mixture value we will get from above. So first, oxygen has 2 more number of moles. CV of the oxygen. So CV value we have already calculated. That is F into R by 2. So this is another method. I hope you got the gist of it. Not the shortest method, but you should know. Okay. So correct answer here is option C. Thank you so much. Hello. Variation of kinetic energy Ke for a particle executing simple harmonic motion with a displacement x starting from mean position to extreme position is given as. So options are basically graphs, kinetic energy versus position graph. First option is a straight line, second option is a curve increasing value, then option C is again a curve but decreasing value, and option D is straight line passing through origin. So here we have to recollect formula for kinetic energy in SHM. So kinetic energy in simple harmonic motion is half m omega square a square minus x square. Okay, so we can open this bracket and rewrite the things half m omega square with minus sign. Okay, let me first open the bracket regularly. Let's say multiply by a square and then half m omega square x square. Now notice that this entire thing is a constant, half m omega square. In this formula, K is kinetic energy, m is mass of the body performing simple harmonic motion, omega is the angular frequency of the SHM, capital A is the amplitude of the SHM, x is the displacement of the body from the mean position. Okay, so here if I rewrite this, then kinetic energy stays here. This entire term with x square, I am keeping it in a bracket, into x square plus this entire term I am calling it as C. Okay, this entire thing, it's constant, half m omega square a square, they are constant, so I am keeping them as just C. Now the idea is, on y-axis we have kinetic energy, on x-axis if you take displacement, then can you notice this? Here there is some constant, let's say just a random constant, any constant, you can take any constant, doesn't really matter. P, you can take P as a constant, x square plus C. So what is this? This is equation of straight line? No, for straight line it should be y equal to mx plus c. Power of y will be 1, power of x will also be 1. So this is not a straight line at all. As per a graph A, kinetic energy remains constant with respect to position. That is absolutely wrong. Kinetic energy changes. Then in option D also we are getting a straight line. So if you're getting a straight line and that is a slope positive straight line, that means as your displacement increases, kinetic energy is increasing. Okay, that is also wrong. And even before that, it's a straight line and my calculation tells me that it is going to be a curve, a typical parabola shaped curve. Right, this is matching with the standard equation of parabola, y equal to ax square plus bx plus c. So here it is equation of parabola, so it will be a curve, not be a straight line. So D also we can eliminate. Now where there is C and then there is B, that we can verify very easily. Put x equal to 0 in the kinetic energy formula, or here put x equal to 0. So if I put x equal to 0, then y equal to C. There is y intercept. So when x is 0, y should not be 0. But in option B, you can see it starts from 0, 0. But the equation doesn't fulfill that condition. If I put x equal to 0, y value is not 0. It is some constant. So that's why option B is also wrong, because it is starting from 0, 0. So the only correct answer here is option C. Okay. See, here I went with the mathematical approach. First I got the equation and then I went for elimination. You can eliminate few things directly by just knowledge of SHM. That in SHM, total energy, in ideal SHM, total energy remains constant. Kinetic energy is maximum at mean position and then becomes 0 at extreme position. Kinetic energy is maximum at mean position and becomes 0 at extreme position. So as your position is changing from origin to amplitude, kinetic energy should decrease. Here kinetic energy is increasing, that's why it is wrong. Okay, here also kinetic energy increasing, that's why it is wrong. Okay, here the analysis fits perfectly. When you are at mean position, kinetic energy maximum, and as you go away from the mean position towards extreme, kinetic energy decreases. At extreme it becomes 0. Okay, so we can do this analysis and get the answer without calculation as well. In option B, main problem is it starts with 0, 0. So I can say at mean position kinetic energy is not 0, it is maximum. So that's why B option is also wrong. So one is the mathematical approach to get the answer. You try to get an equation between the x and y variable and then try to match it with the standard equation. Is it a straight line, parabola, hyperbola, ellipse, rectangular, hyperbola, etc. And the other is by just knowledge of SHM. We know where energy is maximum, where energy is minimum. So we can analyze that with all the 4 graphs and eliminate. Only C will be remaining. So correct answer is C. Thank you. Hello. A certain galvanometer have a fixed core made up of non-magnetic metallic material. So metallic means it is conductor, but it is not a magnetic material. It will not get magnetized. Function of this metallic material is to bring coil to rest quickly, to oscillate the coil in the magnetic field for the longer period of time, to make the magnetic field radial, to produce large deflecting torque on the coil. So if we look at the working, let's have a look on a schematic diagram, as you can see, for galvanometer. So when current passes through the coil, you can see when current passes through the coil, that coil which is wrapped around the core will get magnetized. I mean, that coil will behave like a magnet. That coil will behave like a current carrying coil will behave like a magnet. And because of that magnet present in the magnetic field of north and south pole, there is a permanent magnet north pole, south pole, coil will rotate because of the torque, and then along with that pointer will also rotate, and it will give you some reading on the scale. But when pointer stops at a point, it stops at a point because the net torque at that point becomes 0. Which two torques are balancing here? So torque of the magnetic spring, magnetic field, and torque of the spring which is attached below the core. Now these two torque becomes equal and opposite. That's why the magnet or the coil, not magnet, coil stops at that point. But it is very much possible that by the time it reaches over there, by the time it reaches the equilibrium condition, it has acquired some velocity, some angular velocity, and because of that angular velocity, it may overshoot that equilibrium position and it may start doing oscillation. Okay, so it will not like slowly will reach the equilibrium. As soon as you pass the current, it will go like this. So to stop the oscillation quickly, we put a metallic core, as when the coil rotates, metallic core will rotate, and that is present in a magnetic field. So because a metal present in the magnetic field is moving, there will be eddy currents generated. Eddy currents will be circular currents in the metallic conductor, and those eddy currents will resist further movement of the coil. They will oppose the oscillation of the coil. As per Faraday's law, we know that whenever current is induced, it will oppose the cause of EMF generation. So here the coil moving, doing oscillation is responsible for induced current, eddy current. So induced current will get induced and will stop that coil itself from the oscillation. It will create a dampening effect. Damping will be done. Because of the damping, coil will not oscillate too much. It will quickly come back to its equilibrium position. Okay, so correct answer is to bring coil to rest quickly. Okay, clear? Option A will be correct. Thank you. Hello. For designing a voltmeter of range 50 volt and ammeter of range 10 milliampere using galvanometer which has coil resistance of 54 ohm, showing a full scale deflection of 1 milliampere as shown in the figure. So we have to convert a galvanometer into voltmeter as well as into ammeter, and for that there are various values given in the statement. There are 5 statements A, B, C, D, and various values of capital R and various values of small r are given. So which statement out of given 5 statements, which 2 statements are correct, that we have to find out. So Let's first start with conversion of galvanometer into voltmeter. So to do that, we put a very high resistance in series combination. So in that case, formula for voltage will be equal to current passing through galvanometer into G plus R, where G is the resistance of the galvanometer, R is resistance that we will add in series combination, and V is potential difference that is being measured. Now you can see that G and R are constant for the given arrangement. As long as the resistor and the coil is same, G and R value will be constant. What will change is potential which is being measured. If the potential which is being measured increases, then the IG value, current passing through galvanometer, will also increase. So if you want maximum measurement, then current passing through galvanometer will also be at its maximum value, which is called as full scale deflection. This is called as full scale deflection. Now you put the value of Vmax. Vmax, maximum voltage that we need to measure, is 50, equal to maximum current that we can pass through galvanometer is 1 milliampere given in the question. So this will be 1 milliampere, milli 10 raised to minus 3. Galvanometer resistance is 54 and the resistance R unknown. So if I shift this will be 50 into 10 raised to plus 3 minus 54 equal to R. After 10 raised to minus 3 goes on the other side, it will be 50 into 10 raised to plus 3. On the other side, 54 plus R, 54 goes on the other side. Now look at this number. This is 50,000 in comparison to 54. It's a very big number. So what we can say, R is approximately equal to 50,000 into 10 raised to 15 to 10 raised to 3 ohm. Okay. So we can say R is approximately 50 kilo ohm. Okay. So this is one of the answer. R is 50 kilo ohm, capital R. So based on this, we can say statement A is correct. And if statement A is correct, then statement D is wrong, statement E is wrong. Right? All three are describing the same thing. So capital R value we got 50 from the calculation. So D statement, E statement is incorrect. A statement is correct. Now if statement A is correct, then see, option B cannot be true. Option B cannot be true because there is absence of A here. Then option D also cannot be true because there is no option statement A in the given option. Statement A is not there. So here you can see statement A is correct. Now we have to solve for B or C. So between B and C, what is true? So that is conversion of galvanometer into ammeter. So to do that, what we do? We put a very small resistance in parallel combination called as shunt. So we can write down current is equal to Ig into G plus S upon S. Okay, this is the formula for measuring current when you convert a galvanometer into ammeter. Now Gs upon S are constant for the given galvanometer, for the given shunt. These values are constant. As the current being measured which increases, the Ig value will increase. So when current passing through galvanometer is maximum, when it is Ig max, also called as full scale deflection, then the current being measured will be maximum current. Okay. Now we can put the value of current. Current maximum is 10 milliampere, milli, so 10 raised to minus 3, equal to corresponding current through galvanometer will also be maximum. That is 1 milliampere Ig max value. So 1 into 10 raised to minus 3. And then after that, we can put G and S value. So G value is galvanometer resistance, which is 54. Shunt resistance we have to find out. Okay. These two are shunt resistance. So 10 raised to minus 3 gone. This will be 10 into shunt equal to 54 into shunt. 54 plus shunt. Now we can complete the calculation. This plus shunt will be shifted to the other side. It will become minus 9s. Okay, it will become 9 times S equal to 54. Okay. And if you divide 9 on the other side, 54 by 9, that will be 6 ohm. Okay, so shunt value will be 6 ohm. So the small r value that we have to put in parallel combination is 6 ohm. So 6 ohm, 6 ohm, 6 ohm is present in statement C. So statement B will be incorrect. A and C are correct. A and C correct. That means final answer is option C. Thank you. Hello. A vessel of depth D, half filled with oil of refractive index N1 and the other half is filled with water of refractive index N2. Apparent depth of this vessel when view from above will be. So we can first visualize this. Let's say this is the container and half of it is filled with a oil, an oil of refractive index N1. Oil of refractive index N1. The other half is filled with water having refractive index N2. But it is half of. So if the complete height of the container is, let's say, h, then this will be h by 2, h by 2. Okay, or I can use different alphabet as well. Let me use different alphabet. D, complete height D, and here it is d by 2, d by 2. Now when you observe this from outside, then what is the apparent depth for the base of the container? So for such kind of cases, we have formula for h dash, which is the apparent depth, equal to mu of observer, refractive index of the medium in which observer is present, multiplied by summation of h by mu. Summation means addition of which function, which ratio, h upon mu. So let's apply this. H dash is the apparent depth. Mu observer is by default in air. So refractive index 1. Now how do we arrange this summation point? So summation of what? H upon mu. So we will measure real depth of the medium divided by refractive index of the same medium. So real depth is d by 2. Real depth is d by 2 divided by its refractive index n1 plus the next medium. The next medium's real depth is also d by 2 divided by refractive index n2. Okay, so real depth d by 2, refractive index n1, real depth d by 2, refractive index n2. Now we can simplify this. So d by 2 taken common and then you can cross multiply. So n2 plus n1 upon n1 n2. So this is h dash value. Okay, so do we have option like this? D into n plus 1 upon 2 into n1 n2. D, yes, option C is correct. Okay, that's all. Thank you. Hello. Work function of aluminum and gold are 4.1 electron volt, 5.1 electron volt respectively. The ratio of the slope of stopping potential versus frequency plot. Ratio of slope of stopping potential versus frequency plot for gold to that of aluminum is. So the graph that we need to draw is stopping potential V0 versus the frequency of the falling photon. Now to get the graph, we can start with the Einstein's equation, which is energy of the falling photon h nu is equal to work function phi naught plus Ke max. Right? Now we can rearrange this. Before that, I can replace kinetic energy of the electron will be equal to E into V0. Okay, so this is a standard relation between kinetic energy and stopping potential. Work done by the battery to stop the electron will be charge multiplied by potential difference. Charge is electron charge, negative, multiplied by potential difference applied by the battery V0, and that is equal to loss in kinetic energy. So when you will be successfully able to stop the current, that means electrons will stop, their kinetic energy will be 0. So their initial kinetic energy, that will be the maximum kinetic energy. So we can use K max is equal to E times V naught. Okay. So this is a standard formula to get stopping potential. Now we have to arrange V naught on y-axis. So I will divide entire equation by E. So I'm getting H upon E times nu naught and times nu, then work function phi naught upon nu upon E plus V naught. Okay, here also we will divide by E, but E and E cancel. So dividing both sides by E. Now I will rearrange this. So this V naught will stay on the same side. H by E also will stay on the same side. Okay, this term will be shifted to the other side. That will give us minus phi naught by E. Now look at this equation carefully. This is matching with y equal to mx plus c. If I compare this, V naught will go on y-axis, frequency will go on x-axis. So it is y equal to mx plus c, isn't it? So your c will give you work function by, your c means y-intercept will give you work function divided by E, and slope will give you h by E. Okay, so slope of such a graph will give you h by E. If you draw the graph, then graph will look like this. Slope of this graph will be h upon E, and this y-intercept will give you work function upon E. Now the key idea is this is drawn for a particular metal. When I will change the metal, then work function will change. So look at the answer carefully. Work function will change the y-intercept. Work function changes, so y-intercept will change, but the slope value will still remain same. For a different material, work function value will be different. So y-intercept will be different, but slope value will be still same. So if I solve for any other metal, okay, the line that we will get will be like this. So it will cut the y-axis at a different location. If I take one more material, then like this, it is cutting y-axis at a different location. So work function will be different for different metals, but all of them have same slope. All of them have same slope. So if you go for ratio of the slope of two metals, maybe gold and aluminium, but any material, as long as if it is happening, ratio of the slope will be 1:1, because for all the graph, slope will be same, h by E, independent of the metal. Slope is independent of the metal. So ratio will be 1:1. Thank you. Hello. Different combinations of three resistors of equal resistance R are shown in the figures. Increasing order of the power dissipation is, and if you observe all four diagrams, you can see that current is same in all of them. So if the current is same and we have to comment on the power, then I will use formula for power. So we have various formulae for power. Electric power is V square by R, I square R, then V into R. Okay, V into R is also formula. We will use I square R formula in this case, because all of them have same current passing through them. Current is same for all of them. So I can comment on the power just based on the resistance, directly proportional. So now you can solve all four combinations to get the effective resistance. So if I start with D, it is simple series combination. So here effective resistance will be 3 times R. Then option C, graph C, figure C has 3 resistors identical in parallel combination. So if we have identical resistors in parallel combination, formula is R by N, where R is the value of single resistor, N stands for number of those identical resistors. Here it is 3, so that is R by 3. Then for solving circuit B, look at this, R and R, 2R. So these two are in series combination, so their effective will be 2R, and that 2R and the remaining R are in parallel combination. So for only two resistors in parallel combination, we can solve it by R1 into R2 upon R1 plus R2. That will be 3R. So R and R cancel, 2 by 3 times R. And finally, for the last circuit, we'll rewrite this later. For the last circuit, notice that these R are in parallel combination. So again, identical resistors in parallel combination. So this will be R divided by 2. Identical resistors in parallel combination is R by N. Here 2 resistors in parallel combination, so R by 2. And the third one is R. So if I simplify this, we have to simply add these two because they are in series combination. So 3R by 2. So notice how the resistance is. Okay. We have to arrange in the increasing order of power. So least of the resistance, can you see least of the resistance? Least of the resistance is R by 3. Then we have 2R by 3. Okay. Then we have 3R by 2. And then finally 3R. Okay. So notice power, as we wrote earlier, I will rewrite it. Power, electrical power is I square R. Current is same in all 4 combinations. So power is proportional to R. So the one having higher resistance will have higher power. And we have to arrange in the increasing order. So the lowest one first. So R by 3 is the minimum resistance, and minimum resistance is for which? R by 3 is for which circuit? D. So this is for D. 2R by 3 is for B. 3R by 2 is for A, and 3R is for D. 3R is for D, and R by 3 is for C. So this is the order of increasing order of the resistance. Same will be increasing order of power. So power at C will be lesser than power for B, then power for A, then power for D. Okay, so correct answer will be option A. Thank you. Hello. N moles of a perfect gas undergo cyclic process A, B, C, A. See figure consists of following process. AB is isothermal expansion at temperature T so that the volume is doubled from V1 to V2. V2 is twice V1. And pressure changes from P1 to P2. This is AB process. Now BC process is isobaric compression at pressure P2 to initial volume V1. C to A, isochoric change leading to change of pressure from P2 to P1. Work done, total work done in the complete cycle A, B, C, A. So you can see the graph also, it is pressure versus volume graph, and A, B, C, A loop is visible. So this is cyclic process. For a cyclic process, we can calculate area of the loop, and that is equal to work done. But here the shape is not a standard shape like rectangle, triangle, so we cannot calculate area directly. But it is very clear that there is some area enclosed by A, B, C. There is some area enclosed by ABC loop. So definitely answer is not 0. Definitely answer is not 0. So we can eliminate option A. Option A cannot be true. Okay. Now to calculate work done, what we can do? We can calculate work done in 3 parts, 3 processes. Work done from A to B process, work done from B to C, and work done from C to A. Now notice work done from just C to A. What is happening in C to A process? Isochoric change. Isochoric means volume constant. Yes, isochoric means volume constant. So if volume is constant, then thermodynamic work done is 0. Work done is P delta V, right? Since volume is constant, work done is 0. So this is directly 0. That value will be directly 0. Okay, this value will become 0. Then work done from A to B process. A to B is isothermal process. So for isothermal process, we have various formula for work done. One of them is nRT ln of V2 divided by V1 plus work done from B to C process. Work done from B to C. Now B to C is isobaric process. Pressure is constant at P2. So we can write down pressure P2 and change in volume. Change in volume is final volume minus initial volume. So final volume is V1, initial volume is V2. Okay, and CA work done. is 0. C2A is, as we discussed, isochoric process. So we can put values here, whatever values we know. So nRT, this will be ln of V2 is twice V1 as per question. And here we can do the same thing. We can replace V2 as twice V1 or V1 as V2 by 2. So if I replace V1, then it will be V2 divided by 2. As it is given in the question, volume V2 is twice V1. So V1 can be V2 by 2. So that's what I did here. V1 replaced as V2 by 2 minus V2. And here V1 cancel. So we can take nRT ln of 2. So now look at the options. We are going in the right direction. Plus, now this will be actually subtraction of V2 by 2 minus V2 will be negative. So we will get minus half P2 V2. Okay, minus half P2 V2. Now, right now answers are not in terms of P2 V2. All answers are in terms of nRT. So what we can do? We can replace P2 V2 in terms of nRT. How? So P2 V2 is basically pressure and volume at point B. Pressure and volume at point B are V2 and P2. So since A to B is isothermal process, for isothermal process we can write that for A to B cycle we can write that P1 V1, that means initial pressure, initial volume, is equal to P2 V2, that is final pressure, final volume, is equal to nRT, since it is isothermal process. So that's what I'm going to do now. I'm going to replace P2 V2 as nRT, and then question is solved. So P2 V2 replaced as nRT. Take nRT common. nRT taken common, this 2 will be there. So answer will be ln of 2 minus half. Okay, that is the total work done. There is some portion going little outside. So let me write here. So after taking nRT common, whatever is remaining, that will be your answer. Work done is equal to nRT bracket ln of 2 remaining and half is remaining. So this is our final answer for work done. Okay, so correct answer will be option B. Thank you. Hello. In the given figure, energy levels of hydrogen atom have been shown along with some transitions marked as A, B, C, D and E. The transitions A, B, C represents, okay, A, B, C respectively represents, and you can see the energy level diagram. And in the options, we have various descriptions: series limit of Lehman series, third member of Balmer series, second member of Paschen series, ionization potential of hydrogen, then second member of Balmer series, then third member of Paschen series, etc. Okay, you can read all options. Now, to understand this A, B and C, let's go a little close to the diagram. Okay, now we are very close to diagram. I hope it is visible to you. Now we have to comment on A, B, C. So now look at the A. Look at A transition. A transition is from 0. A transition starts from 0 to 1. So from 0 to 1, 0 means from infinity, orbit number will be infinity, energy will be 0. So from infinity to n equal to 1. So whenever electron jumps from any higher orbit to n equal to 1, that is counted as Lehman series. So when you jump from the immediate next orbit, that is first line, and so on. When you jump from the farthest orbit, that is infinity, to that orbit, n equal to 1, that is the last line of Lehman series. Lehman series last line will be jump from the farthest possible orbit, that is infinity to 1. And when orbit is infinity, orbit number is infinity, that means energy is 0 over there. Now from 0 to 1, that means from infinity to 1, that is the last line of Lehman series. Lehman series, I will repeat once again, Lehman series is the collection of photons which will be emitted when electron from any higher orbit jumps to first orbit. So 2 to 1 first line, 3 to 1 second line, 4 to 1 third line, infinity to 1 last line. Okay, so A indicates last line of Lehman series. So last line of Lehman series, also called as series limit of Lehman series. Series limit of Lehman series. Okay, this is available in two options, option A, option D. Now I will show it to you. Okay, you can see which two options I have selected, A and D. Okay, because A option is giving us same information, series limit of Lehman series, series limit of Lehman series between A and C. Now let's solve for B and C as well. Okay, so for B, observe carefully how B is moving. In transition B, from where to where? In transition B, I can see electron is jumping from n equal to 4, no, n equal to 5. It is jumping from n equal to 5 to n equal to 2. Jump is from 5 to 2. From 5 to 2. So jump is to second orbit. Second orbit means, that means Lehman-Balmer series. L, BP, BP. Lehman-Balmer, B for Balmer series. And in Balmer series, if the jump is from the immediately next orbit, so from 3 to 2, that is first line, 4 to 2, that is second line, 5 to 2, that is third line. So in transition B, electron is jumping from 5 to 2, right? Electron is jumping from 5 to 2. So this becomes third line. See, and if you get confused, just subtract them. 5 minus 2, 3. So that's the third line of the Lehman series. Balmer series. Third line of the Balmer series. So third line of the Balmer series is mentioned appropriately in option A. You can see that. Okay. Here it's second member of Balmer series, but no, second member will be jump from 4 to 2. That will be second member. Okay, but this is third member which is asked in the question, transition B. So third member is only in one option. So option A has to be correct. Now, just for the purpose of learning, if I solve, just for the verification, if I solve for the last part, that is C as well. So in C, you can notice that jump is from 5 to 3. So jump is from higher orbit to n equal to 3. So Lehman, Balmer, Paschen, this is Paschen series. Jump from any higher orbit to n equal to 3, that is Paschen series. Now if the jump is from the closest higher orbit, 4 to 3, if it is 4 to 3, if it is 4 to 3, if it is 4 to 3, that means it is first line. If it is 5 to 3, that means it is second line. So it is 5 to 3 jump. So this is second line of Paschen series. Second line of Paschen series. Okay, if I draw it for you here, this is n equal to 1, this is n equal to 2, n equal to 3, n equal to 4, n equal to 5. So when electron jumps from any higher orbit to n equal to 1, that is Lehman series. Any higher orbit to n equal to 2, that is Balmer series. Now any higher orbit to n equal to 3, that is Paschen series. Now if it jumps from fifth orbit to third orbit, that is second line. First line will be from the closest higher orbit, 4 to 1. Okay, so what is the correct answer, the correct description for the C? It is second line, second member of Paschen series. Paschen series, jump from higher orbit to n equal to 3. Jump from the immediately higher orbit will be 4 to 3, that is first line. 5 to 3 will be second line. So second member of Paschen series. So even this part is correct. So we can say option A is correct. Thank you. Hello. A cube of side A has point charge plus Q located at each of its vertices except at origin, where the charge is minus Q. Electric field at the center of the cube is. You can see that the figure is shown there is cube, side of the cube is A. There are total 8 corners for the cube. Out of those 8 corners, 7 corners have same charge plus Q. At the 8th corner, the remaining one, which is origin, the charge is minus Q. And here we have to calculate net electric field at the center of the cube. And you can see answers are in vector form, I cap, j cap, k cap. Instead of I cap, j cap, k cap, it is x cap, y cap, j cap. So they will serve the purpose of I cap, j cap, k cap. Answers in terms of plus q or plus 2q, minus q, minus 2q. Denominator is same, 3 root 3 epsilon naught pi a square. This part is same. The vector is also same. Okay, in the numerator only we have to solve carefully. So here, first visualize how the exact arrangement is. Okay, so to visualize that, let's check out this. Okay, so look at this. This is the arrangement, and at every corner there is one positive charge except the origin. Okay, you can see the origin has charge negative. So because of the symmetry of the shape, every charge will be equidistant from the center of the cube, isn't it? Because of the symmetry of the shape, every charge will be equidistant from the center of the cube. Let me show you center of the cube as well. So can you see that orange dot? That orange dot is center of the cube, and that is equidistant from every point, every corner. So what will happen because of this? If I show you one of the diagonal, so look at this diagonal line. Look at this diagonal line. Charge at the end of these diagonals are equal. Both of them are positive, same magnitude. They both charges are at the same distance from the center of the cube. So the electric field that will be produced by both of these charges will be, they are away. So away from the charge. So this charge, the one which is at this end, this one, will produce electric field away from itself, and the diagonally opposite one up top, that will also produce electric field away from itself. So at the center, these two vectors will cancel each other. Equal magnitude, opposite direction. Charge is same. Perpendicular distance, or that the distance of the charge from the center is also same. And they are along the same line. Opposite vectors, equal in value, opposite direction, resultant will be 0. So diagonally, these vectors will cancel each other's, these two charges will cancel each other's electric field. So diagonally resultant is 0. Now this is not only for this diagonal. Let me show you one more diagonal. You can see the next diagonal on the screen. For this diagonal as well, net electric field will be cancelled because of the same explanation, same reasoning. And for this diagonal as well. Okay, I am showing the third diagonal now. Even for this third diagonal, same thing will happen. Now this will not be true for the fourth and the last diagonal, which is this diagonal. And this diagonal is particularly connecting origin, where the charge is minus q, to diametrically opposite point, the opposite vertices, where charge is plus q. Here there will be no cancellation of electric field. So if you just focus on that diagonal, I will remove other diagonals. Now you can focus on that diagonal. So here charge at the center, at the origin, will produce electric field towards the charge. Negative charges will produce electric field towards the charge, and the exactly opposite vertices has a positive charge that will produce electric field away from the charge. So both of them will have resultant at point center of the cube. Okay, so with this animation clear, we can go back to our calculation. So let's complete the calculation now. So this is the center. How will you reach the center? To reach the center, we will travel a by 2 distance on x-axis or on y-axis. If I travel a by 2, half of the side on x-axis, half of the side on y-axis, and half of the side on z-axis, then I will reach the center of the cube. Okay, this is center of the cube. And as we discussed, other diagonals will cancel each other's electric field. Value will be equal, direction will be opposite. What is formula for electric field by a point charge? Formula for magnitude is K into Q upon R square, where K is Coulomb's constant, 1 upon 4 pi epsilon naught. Q is the charge, point charge, and r is the distance of that point charge from the point where we are measuring electric field. Now here in this case, this electric field will be produced by all the 6 diagonally opposite charges. At the center it will be equal and opposite. If I draw it for you, it will be, for this positive charge it will be directed away like this, and for this positive it will be directed away and like this. So diagonally they are cancelling each other, as we saw in the animation also. Diagonally they will cancel each other. So this kind of cancellation will happen for the 3 of the diagonals. So this is the one diagonal where the value of the electric field by opposite charges will be equal, direction opposite, resultant 0. Okay, same for this diagonal as well, same for this diagonal as well. So 3 diagonals will have 0 electric field. Resultant will be 0 for these 3 diagonals. Now the remaining is only the 4th diagonal. Now the charge at the center is negative, so electric field will be directed towards the charge, whereas charge at the opposite vertices is positive, so for that positive, electric field will be directed away from the charge. So both the electric field by the negative charge will be towards the charge, electric field by the positive charge will also be towards the negative charge. Positive charge, electric field is towards itself. Sorry, positive charge, electric field is away from itself. Negative charge, electric field will be towards itself. So on that diagonal, if you just focus on that diagonal, okay, this is center of the diagonal. One side has positive charge, one side has negative charge. I'm showing the diagonal outside. So for positive charge, electric field will be away. For negative charge, electric field will be towards. So when you go for the net electric field, that will be twice the electric field of any one charge. So if I calculate electric field by the negative charge, that is charge at the origin. So that charge magnitude is Q divided by distance. Now distance is distance of origin from the center of the cube. So here we have to take help of geometry. Okay, and also one thing, we have to write answer in terms of vectors. So this is formula only for magnitude of the electric field. If I have to write down in vector format, then what I will do, I will draw a vector, position vector from the charge to the point where the electric field is being applied. So I will start in position vector from the minus q, from the origin to the point where the electric field is being applied. So that position vector can be taken as r bar. Now that r bar divided by its own magnitude will give me r cap. R bar divided by its own magnitude will give me r cap, unit vector in the direction of r bar, and magnitude will be this 2kq upon r square. Now since we have to write vector form as well, so while using vector form I will take the charge value with the sign. This is formula only for magnitude, but now we are solving magnitude as well as direction together, so I will take charge with its sign. Okay, so charge with sign will have minus q, okay, into r bar upon r. Why are we using minus sign now? Because the original formula that I wrote, that was only for the magnitude, but now I am writing not only magnitude, direction as well. So while using direction along with the magnitude, I have to take the sign of the charge, whatever it is. I will multiply it by unit vector, and this vector will be drawn from the charge where the electric field is being produced to the point where the electric field is being applied, where the electric field is being studied. So here I am calculating electric field by the charge at the origin to the electric field at the center of the cube. So vector will start from origin to center of the cube, that is r bar. Now r bar divided by r magnitude, that is simply r, is r cap, that is the unit vector, and kq minus 2k minus q divided by r square, that is the magnitude. Minus sign is considered because we are writing both the things, direction as well as magnitude together, so minus sign will be considered. Okay, now we can simplify this. To simplify this, we will need one thing, and that is r vector. We will need r vector. So how will I get r vector? R vector will be a vector starting from the center going towards the midpoint. So I will remove this, and what will be coordinates of the center? Center coordinates will be, suppose this is center, I'm writing center coordinates here, and the center coordinates will be a by 2, comma a by 2, comma a by 2. Simple geometry. We will travel a by 2 on x-axis vertically. We will travel a by 2 parallel to y-axis, and we will travel a by 2 parallel to z-axis to reach the center. So x and y coordinate, z coordinate are a by 2, a by 2, a by 2. So I will get r bar easily. So I'm writing r bar here. R bar will be equal to, we have the coordinates of the point C, and if I draw its position vector, that is my r bar. So a by 2 I cap. In the question, instead of I cap, they have used symbols x cap, y cap, z cap. So we will use them. So a by 2 x cap plus a by 2 y cap, and then a by 2 z cap. We can take this common. If I take this common, a by 2 common, we have simply x cap plus y cap plus z cap. So r bar value is ready. Clear? Now we can calculate for r cap, or just magnitude of r. So magnitude of r we can solve here, mod of r bar, which is simply r. So a by 2 will be taken out as it is, and here we'll do under root sum of square of coefficient. So that will be under root of 1 square plus 1 square plus 1 square. So that is giving me root of 3 into a divided by 2. Okay, now it's time to substitute this in this particular formula that we have set. Okay, so if I start putting values in this, then net electric field will be equal to 2 into k value is 1 upon 4 pi epsilon naught. Okay, Coulomb's constant. Then there is minus q into r bar. So divide by, see, r square is there and r is also there. So if I multiply them, that will become r cube. So here I will combine r cube, but r value is readily available above this. So we will use this r value and we'll do cube of it. So that cube will be root 3 a by 2 cube. Okay, multiplied by r bar. So this is the r bar value, a by 2 into x cap plus y cap plus z cap. Okay, visible? Now we have to simplify this. So what we can cancel? 2 and 2 cancel. In the denominator there is root 3 by 2, root 3a by 2 cube. So 2 cube will become 8 in the numerator. So we can write minus 8 minus 8 cube. Okay, in the denominator there is 4 pi epsilon naught, and this will be root 3a cube. So root 3a cube will be root 3 into root 3, 3, and one more root 3 will be remaining. Okay, I hope this mathematics is clear to all of you. Root 3 cube we have to solve. So that will be root 3 into root 3 into root 3. So root 3 into root 3 square, that will become 3. So 3 root 3. Okay, so come back here. In the denominator we will have 3 root 3 a cube. Okay, and in the numerator we have a, and the rest of the terms as it is, x cap plus y cap plus z cap. Now We just have to cancel the common terms. So a cancelled. Okay, we have a square in the denominator. We can cancel this 4 and this 8 also. So 2 will be there in the numerator. And I think that is it. We cannot do any more simplification. So if I just write down the final answer here, what will be final answer? It will be minus 2q in the numerator. Along with that, we have x cap plus y cap plus z cap. Okay. And in the denominator, what do we have? In the denominator, we have 3 root 3 epsilon naught pi a square. Okay. So this is equally question of electrostatics, equally question of vectors as well. Okay. So this is our final answer. So final answer for this one will be option B. Right? Yes. Thank you. Hello. Velocity time graph has the shape AMB. What should be the shape of corresponding acceleration time graph? So you are given with the graph of velocity versus time, and in options there is acceleration versus time graph. You can see option A, B, and there is option C, D as well. Now, how will you calculate velocity? How will you calculate acceleration time graph from velocity time graph? So we know that acceleration is rate of change of velocity, dv by dt. Now, graphically, what is the meaning of derivative? It is slope. So slope of tangent drawn to v versus t curve. Okay, we know this concept. Acceleration is rate of change of velocity, and graphically, if you have velocity versus time graph, velocity versus time curve, then slope of tangent drawn to that line will give you velocity acceleration value at that point. Now here the velocity curve is not really a curve because it's a straight line variation. So A to M, it's a straight line, then M to B also it's a straight line. So here we don't have to draw any special tangent. That straight line is tangent only. So we'll calculate the slope of that line. Now to calculate slope of that line, you don't have to actually calculate the value. We just need to understand that angle of the line AM with positive x-axis is obtuse angle. So if the angle is obtuse angle is more than 90, then we know that slope in that case will be negative. Slope is negative tan of theta. If angle is more than 90 degree, between 180 and 90, slope value will be negative. Now slope value negative, that means acceleration negative. Here slope stands for slope of VT graph gives you acceleration. So for AM portion, we can say acceleration is negative, and it is constant also, not just negative, it is constant also. From A to M, it is one single straight line. So everywhere you calculate slope, whether you calculate slope in the first quadrant or in the third quadrant, as long as it's the same straight line, slope will be same. So from A all the way up to M, slope is constant and negative. It is negative and constant. Okay. Now similarly, we will solve for this is for AM portion. Let me correct it. This is for AM portion. Now I will solve for MB portion. MB. So for MB portion, focus on MB portion. For MB portion, okay, I'm talking about this line. MB. For this line, you can see that angle made by that line is acute angle. Angle is acute angle less than 90 degree. So slope will be positive, and slope of velocity time graph gives you acceleration. If slope is positive, that means acceleration is positive. So from M all the way up to B, everywhere slope is positive and constant. So it's a single straight line from M to B. So you measure slope anywhere on the straight line, everywhere slope will be same. So from M to B, slope is constant, same slope, and it is positive. So slope here in the graph means acceleration. So acceleration is positive and constant. Okay. So now let's check the option. In option A, slope never goes negative, that is wrong. In option D, slope is negative but it is varying, it is changing, which is not the case. As per the graph, slope will remain constant. When it is negative, it will remain constant in negative. Here in option C, it is negative, positive, but the intervals are not matching. If I go to option A, then that is the perfect representation. For the first A to M situation, all the way from A to M, slope will be negative and constant, and then from M to B, slope will become positive and it will remain constant. Okay, so there's only one time you will find the change in the direction of acceleration. In this option C, you can see it is negative here, positive here, again negative, again positive, which is wrong. As per our calculation, for entire A to M, slope will be negative and it will remain negative all the way from A to M, and then M onwards it is positive and everywhere it will be positive and constant. So correctly, A graph is representing the variation. Okay, so correct option is A. Thank you. Hello. A parallel plate capacitor with a plate area A and distance of separation D is filled with a dielectric. What is the capacitance of the capacitor when the permittivity of the dielectric varies as X is measured along D? Epsilon as a function of X is epsilon naught K plus K into X, epsilon naught plus K into X for the X value between 0 and D by 2, including D by 2. And there is another function for epsilon again function of X, epsilon naught plus K into D minus X. Now this is value applicable for D by 2 to D. X value ranges from D by 2 to D, including both D by 2 and D. Now what will be the effective capacitance of such a capacitor? So first we can visualize this, how it will look. So let's say this is the entire capacitor and this distance is D by 2, this distance is also D by 2. Okay, you can see this. This is a different material whose whose permittivity is given by this equation, and the first part, which is this portion's permittivity, is given by this equation, and we have to calculate effective value of this entire capacitor. So let's focus only on the first part. Let's call capacitance of the first part to be C1 and capacitance of the second part to be C2. So let's solve only for C1. So if you focus only on C1, notice that C1 doesn't have one single epsilon naught value. Epsilon naught value changes with respect to X value. So let's take a tiny slice. We cannot use the regular formula of capacitance. Regular form of capacitance we know. Capacitance, the regular formula will be capacitance is equal to epsilon A by D. We usually write K epsilon naught, but K epsilon naught is basically permittivity of that medium. We write down K into epsilon naught, where K is dielectric constant, epsilon naught is permittivity of free space. So here we are writing directly permittivity of that medium, epsilon into A upon D. Now here A value is constant, fine. D value is constant, fine. But epsilon value is not constant. As you walk from left to right side in the direction of D, then your epsilon value is continuously changing. So what we will do here to solve this problem, we will consider an infinitesimally tiny slice like this. Let's say that slice is at a distance of X from the left side and thickness of that tiny slice is dx. So for this tiny slice, its thickness is infinitesimally small That means dx is very close to 0 but not equal to 0. So only for that tiny portion I can assume capacitance to be constant, or rather I should say permittivity is constant. Otherwise permittivity is changing when you go from one side to the other side in the entire capacitor region. But for that tiny infinitesimally small interval, it is so small that we can consider permittivity to be constant. So what will be the capacitance of that one tiny slice? We can calculate that. Likewise, we can take more such slices between the left and the right side. We can divide that entire space into small number of slices, all of them of thickness dx. So for each of them, I can treat them like a very thin, narrow, long, parallel plate capacitor. Because for that infinitesimally small thickness, since permittivity becomes constant, we can use a regular formula of capacitance, which is this epsilon naught A by D. So what I'm going to do, I'm going to make slice and calculate capacitance of that slice. Likewise, there will be n number of slices we can make between the entire plates, and then these all will be in which combination? If I separate all these slices, it will look like this. What is this? This is series combination of these tiny slices. So for series combination of capacitors, we know how to get effective capacitance. It is 1 upon C1 plus 1 upon C2 plus 1 upon C3. So basically addition of the capacitance, that will give you addition of reciprocal of capacitance, that will give you reciprocal of effective capacitance. So exactly that concept we're going to use here. So adding reciprocal of capacitance for every single slice, and then we'll get the capacitance of the entire capacitor. So let's go and solve this. I will clear this space and we will start with the calculation. So we know the capacitance formula is this, but I'm solving for tiny capacitor of thickness dx, and I'm going to add their reciprocals. So d1 by c. Okay, starting with d1 by c. That will be a reciprocal of this tiny capacitance formula written for dx thickness. So in the numerator there will be thickness of the capacitor. So here the dx value is going to be the thickness of that tiny capacitor, that is d. Okay, I'm using a reciprocal of this formula. If I do reciprocal of this formula, I will get 1 by c d epsilon a. Okay, clear? So now let's use dx in place of d. Then epsilon will be replaced by its function, whatever function of epsilon it is given, that is epsilon naught plus k x into area a. Okay, cool. So here 1 upon c is the tiny capacitance of that tiny slice. So reciprocal of that capacitance value is very high. That tiny slice capacitance value is very high, but we have to solve for addition of the reciprocals. Formula is for addition of reciprocals. So it is 1 by dc, or d of 1 by c. That will be a tiny capacitance, that will be a tiny number rather, which can be added to get the final value. So individual c value will not be a elemental thing here. Reciprocal of that capacitance, which is for the tiny space dx, that will be the elemental value, that will be the tiny value which can be added to get the total capacitance. Okay, so let's integrate this. So if I go for integration of 1 by c d1 by c, then dx as it is. Here I can take few things outside. A can be taken outside, and from this term I am taking epsilon naught also common. So if I take epsilon naught common, then I am having 1 plus k by epsilon naught into x. Okay, there will be integration sign, and we'll integrate this from 0 to d by 2. Now why only till d by 2? Because this function is applicable only for the given range 0 to d by 2. Now let's simplify this. So this will give us 1 upon dc equal to 1 upon a epsilon naught outside, and this becomes integration of 1 by 1 plus some constant into x. So this is the constant into x. So you know this integration, this will be ln of 1 plus k by epsilon naught x whole divided by k by epsilon naught. Okay, you know this integration of 1 by x is ln of x, integration of 1 by ln of 1 plus x is also ln of x, integration of ln of 1 plus some constant into x will be again integration of 1 by 1 plus some constant into x will be ln of 1 plus some constant into x divided by that constant itself. Sorry, so the constant or the divided by that coefficient is k by epsilon naught. So we can simplify this, and this will become epsilon naught in the numerator, a epsilon naught k in the denominator, and here I am putting square bracket to put limits, because the limits will be there, it's a definite integration. So limits will go from 0 to d by 2. So here constants will be gone out, epsilon naught cancel, and here we have ln of 1 plus k by epsilon naught x, and limits are d by 2 and 0. Okay, I will just move out of your way. Yeah, cool. Now it is visible. Now let's complete this. So 1 by c will remain as it is. We can simplify this. Ignore my Alexa. We can simplify this. So x value will be replaced as d by 2. So k into d by 2 epsilon naught minus ln of 1. Okay, lower limit is just 0. When you put x equal to 0 in this place, x 0. So ln of 1 is also 0. So ln of 1 is 0. That is gone. Whatever is remaining, we have to just do rearrangement. So if I do reciprocal on both sides or shuffle the numbers, so then c will be equal to, okay, I am writing here now, c will be equal to k a, c will be equal to k a, just a minute, c will be equal to k a will be in the numerator, and this entire bracket will be in the denominator. So what do we have in the denominator? We have ln of 2 epsilon naught plus kd divided by 2 epsilon naught. Okay, so this is capacitance of one single capacitor. This is not the final answer. Wait, hold. This is not the final answer. This is capacitance of one single capacitor. Now, this is what we did for C1. This is what we did for C1. So we should specify now. This is what we did for C1. Now, same calculation we can do for C2 as well. But if you, so approach will be exactly same. The only thing that will differ are the limits. For second part, limit will go from d by 2 to d, and second thing that will change is function. Here the function of epsilon was epsilon naught plus kx. In the second part it will be epsilon naught plus d minus x. That's the only difference. So we can repeat the calculation all over again for the second capacitor, or notice carefully, if you just study that C2 capacitor the variation that is given for C2 capacitor is exactly same as C1 capacitor. The way capacitance changes for C1 capacitor from 0 to D by 2, similarly for the C2 also it changes from D by 2 to D. So it is again the same capacitor. Mathematically the function is different because X value will be different for C2 capacitors. Anything considered in C2 will be further away from the left side. So the shift of origin has been used. If you notice carefully, shift of origin has been used. So one thing that we can do is to solve all over again. But if you observe carefully, it is the same capacitance written all over again. If we put X equal to D by 2, if you put X equal to D by 2 here, then D minus D by 2, that is D by 2. So K into D by 2. Okay. And that will be your answer for same X equal to D by 2. So same answer you are getting here. So capacitance, or if I go for the other extreme, well, X is equal to D. So X is equal to D, that means D minus D, 0. Effective capacitance, this portion will be 0. Here also if you put X equal to 0, answer is 0. So it is the same capacitor, but sequence is opposite. It is the same capacitor, sequence is opposite. So effective capacitance will be same as this one single capacitor, and then you can treat them like two capacitors in series combination, two identical capacitors in series combination. Are you getting it? Understanding this part is very, very important. So C1 and C2 are essentially forming the same capacitors. You can either go by this mathematics and repeat the mathematics with this different function for epsilon, or you can observe the terms carefully and recognize that it is the same pattern which is being repeated again in the reverse sense. Okay. So when I'll solve for the final capacitance, C1 and C2 are two identical capacitors in series combination. So the effective value will be simply C by 2. So C equivalent will be equal to C1 divided by 2. Okay. So C1 divided by 2. So this is our final answer. C1 divided by 2. And where is C1? Here we have C1. So this term divided by 2, that is your final answer. So this term divided by 2 means option B will be correct. Okay, cool. If you want to verify, you can put this same function here and change limits from D by 2 to D. Okay, so correct answer here is option B. Thank you. Hello, two wires of same length and same radius are joined end to end and loaded. Loaded means weight is applied, force is applied to elongate it. Young's moduli of materials of two wires are Y1 and Y2. The combination behaves as a single wire, then its Young's modulus will be. Okay, so let's first understand what is given in the question. We are given with two wires which are of same length, same radius. Same radius means their cross section area will be same. So let's say this is one wire having length L, and after that we are attaching another wire to this wire which is of same length but same cross section area as well. Cross section area for both the rod is same, both the wires is same, but their materials are different. So Young's modulus for the first wire is, let's say, Y1. For the second wire, Young's modulus is Y2. Now we have to solve for the combination, for this series combination. Okay, end-to-end connection means this is end-to-end connection. Okay, now for this series combination we have to solve for effective Young's modulus, which means instead of these two different wires, if I place one single wire which will occupy the same original length, but instead of, and will give me same elongation as well. So if I use another wire in place of these two wires, okay, which will occupy the same volume. Okay, the total volume here will be to L plus L 2L into cross section area A. So here also we will take same wire, same cross section area, and it should occupy the same length. So the total length of this third wire should be 2 times L. That is how we will calculate effective Young's modulus. So there are 2 wires, both wires will show some elongation, there will be some total elongation produced. Now by finding out effective Y value, what essentially are we doing? We are replacing 2 different wires by one single wire, which will give you same total elongation for the same applied force. Dimensions will be such that it will occupy the same volume as the original arrangement, but instead of 2 different wires, now it is one single wire. So what will be its Young's modulus? That is what we have to solve for. Okay, so like we calculate effective resistance, effective capacitance, same thing. So now let's say Young's modulus of this wire is Y effective. Both should have same elongation. So elongation in first wire is, let's say, delta L1. Elongation in the second wire is, let's say, delta L2. And that total elongation will be equal to elongation produced in the effective wire. So now if I recollect Young's modulus formula, then Young's modulus Y is equal to FL upon A into delta L. So delta L becomes FL upon A into Y. Now remember, in the question we are applying same load to get the effective value. Whatever load we are applying on combination of 2 wires, same load we have to apply on this one single wire. So same load we will apply on this one single wire. So load is same. What else is same? We can write down this formula for all the 3 wires. So for first wire, if I write down, load is going to be mg. So instead of F, I'm writing mg. Original length of the wire is L divided by cross section area A into Young's modulus Y1. This is substitution of delta L1. Now we'll do same thing for delta L2. So this will be again same load mg. Its length is also L. Area is also A. Young's modulus is different, Y2. So this is individual elongation in wire 1, wire 2. And now we will solve for the effective wire, where we'll have to apply same load. Length of the effective wire will be 2 times L divided by cross section area has to be same multiplied by Y effective. Okay, let me repeat one more time. Effective means it should give you same output. It should give you same output. It should occupy the same volume, same elongation. Everything will be same. Just only one difference. Instead of 2 different material, it is one single material. That's the only difference. Okay. So that's why the wire that I'm considering, the effective wire, is of same cross section area as the original wires, and the length is 2L, so that it occupies the same volume as the 2 wires were occupying earlier. Okay. That is basically effective wire, and that effective wire's Young's modulus is Y effective in this case. Okay. So now simplify this. We can cancel many things here. mg, mg, mg cancel. L, L, L cancel. A cancel. Whatever is remaining, we have to solve for that. So remaining is 1 by Y1 plus 1 by Y2 equal to 2 by Y effective. Now here what we can do cross multiplication and then reciprocal. So this will become Y1 plus Y2, Y1 into Y2, 2 will go down in the denominator, and that will be 1 by Y effective. Okay. So now that we have Y effective value, we will do reciprocal on both the sides, and that will give us the final answer. So Y effective will be equal to 2 Y1 Y2 upon Y1 plus Y2. Okay, so 2 Y1 Y2 upon Y1 plus Y2. This is our final answer. So do we have any option? 2 Y1 Y2 upon Y1 plus Y2? Yes, option is B. Okay. Now there is one more way in which we can solve this question, and the other way is to solve for the condition. This should be carefully. This is another way to solve the question, that is by using options. Okay, so how will I use options? See, options are giving me effective y value for the series combination. If suppose I joined two identical wires in this combination, y1 y2 is different, two different wires, different Young's modulus. If I join identical wires, then if it's if the two pieces are of identical wire, then it becomes a regular wire only. Then the Young's modulus effective will be equal to the original y value of the wire. Okay, let me repeat one more time. If the formula is made for two different wires having two different Young's modulus, material is different, Young's modulus is different, and then we are solving for effective y value. But if the formula is correct, then it will also fulfill that one super special condition where the two wires that I have taken are coincidentally, they are same wire made up of same material. So in that case, both of them are joined together, then it becomes a regular single wire. And for that single wire, Young's modulus will be its own Young's modulus value. There will be no effective value, because when you join two identical wires together, okay, it's like a one bigger wire. Young's modulus will remain same. So in the options, if I put y1 equal to y2 equal to y, then answer should be again y. So if I try doing that in option A, see, if I try doing that y1, y2, both of them I'm putting as y, and is it matching with the left hand side? So y1, y2, y square in the numerator, and in the denominator it will be 2 plus y. So y and y cancel, not matching. Now if I try this here in the option D, in the numerator we will have y into y square upon y plus y 2y into 2. So here it will be 4 into y. Okay, again this is not matching. Then if you solve for A, then y into y, it will be 2y square divided by y plus y 2y into 3, 6y. Okay, so we can cancel y, but it is not definitely giving us just y value. Only in option B, only in option B, notice, only in option B, if I substitute y equal to y, y1 y2 both equal to y, so in the numerator I am getting 2y square. In the denominator I am getting y1 plus y2, that is y plus y 2y. Okay, so here if I cancel 2 y, remaining is only y. So only for option B that is happening. Okay, if I put y1 y2 equal to y, then it is giving me answer as y. It should give me answer as y, because when I'm keeping two wires together, then it becomes a one single wire, and for that one single wire it's made up of same material, so Young's modulus will be its original Young's modulus value. There is no effective needs to be calculated. Okay, so if the formula is correct, it will satisfy this special condition as well. So what we did, we substituted y1 y2 both equal to y, then the answer should be equal to y. It should match with left hand side, but it is not matching. In three options, only one option you can use this method. Okay, so we should know both the methods while preparing. In the exam hall, whichever method comes to your mind, apply that. Okay, thank you. Hello. A mass m hangs on a massless rod of length L, which rotates at a constant angular speed, angular frequency, and mass m moves with a steady speed in a circular path with constant radius. You can see that in the diagram as well. The radius of that circular motion is r. Assume that the system is in steady circular motion with constant angular velocity omega. The angular momentum of m about point A is LA, and angular momentum of same mass m about point B is LB. Okay, these A and B are on the z-axis. Calculate, based on this we have to figure out what is the correct statement. So LA, LB, angular momentum about point A, about point B, both are constant in magnitude and direction, and other combinations like this, that B is constant in direction but different in magnitude, then B is constant both in magnitude as well as direction, A is constant in both magnitude as well as direction. So out of this we have to select the correct statement. Okay, so first let's visualize this motion happening. So for that, I'm going to help you visualize this. Look at this. Okay, can you see a cone? I mean, can you see the arrangement? Let me move it around for that you to understand. So this is a 3D arrangement of what was given in the question. Okay, and if we play this as as it was described in the question, the motion will look like this. Okay, you can see how it is moving. So the mass is that green color dot, and that is at a position vector which is equal to radius vector. That blue color is actually position from the point A, and that orange color vector is position from point B, which is on the axis. Fine. Okay, so let's go back to the calculation now. So here we need to find out what is the angular momentum about point A. So for angular momentum formula, we know angular momentum for a particle is L bar equal to R bar cross P bar. L bar angular momentum, R bar position vector, P bar linear momentum. So here linear momentum we have to show for this particular mass. It is moving in a horizontal circle with constant angular velocity. So its velocity will be constant. Speed will be constant. Magnitude of the velocity will be constant. So V is equal to R omega, and that will be constant. And that is tangent to the circular path. And R bar will be like this. So let me draw velocity vector like this, and R bar will be position vector. So this is position vector from point A. Now here if I go for calculation of angular momentum for same mass about point A, then it will be writing linear momentum P as mass into velocity. So if I write down mass here, then it will become R bar cross V bar. So R bar here is RA bar cross V bar. So V bar value and R bar value. V bar, R bar, you can see that V bar is velocity tangent to the circular path. R bar is position vector, radius vector from A to M. So this radius is always perpendicular to velocity. Velocity is tangential, radius tangent, perpendicular. So angle between them is 90 degree. So here if I solve for M, R, A, V, sine 90 degree, angle between them is 90 degree. Sine 90 is 1. So magnitude of the angular momentum about point A will be this. RA value is simply radius of the base, radius of the circular path. So MVR sine 91. Now this is the magnitude of the angular momentum about point A, and the direction will be given by, it's a cross product, so direction will be given by right hand rule. We will keep the fingers of your right hand straight along the first vector, which is R bar, and then curl them towards the V bar, that is second vector. And when you do that, when you keep the fingers from A to M and then curl them towards V, thumb will go upward. So if thumb is going upward, then direction of the momentum, angular momentum, will be along this Z axis. This is going to be angular momentum about point A. So wherever the body goes, this R bar cross V bar is always going to be along the axis. Magnitude is also same. So for A, we can definitely say magnitude is also same as well as direction is also constant. No change in magnitude of angular momentum, no change in the direction of angular momentum. It is always along the axis. Okay. Now let's similarly try to calculate angular momentum about point B. So in that case, it will be M R B bar cross V bar. So M is mass of the particle, R B bar means position vector of the same mass but about point B. So about point B, if you draw position vector, then that is going to be the length of that rod, which is L. Okay, distance of mass M from point B will be the length of that weightless rod. Length is L. So what is going to be angle between this R bar or length of the rod and the velocity vector? So this is your R bar. Look at my video. This is your R bar, and velocity vector is in the plane of the circular motion. So as the particle moves, velocity will also move. As the particle moves, velocity will also move. So angle between them is still 90 degree. Angle between them is still 90 degree. So this is your R bar and this finger is V bar. So as the particle moves, this is how it will move. Angle between them is still 90 degree. So if I calculate here, it is m rb bar into v into sine of 90. Okay, cool. Now sine 91, rb bar is going to be just length of the rod into v. So magnitude is constant for lb, but what about direction? So direction will be obtained by r bar cross v bar. Cross product has to be done. So you have to keep the fingers of your r bar, fingers of your right hand, in the direction of r bar, in the direction of l bar, and then curl them towards the b bar. So if you do that, okay, I will do it separately on this side. Let's do it here. So this is going to be r bar, and velocity vector is in the plane of the circular motion, okay, going like this, v bar. So if you do cross product here, for that I will have to shift this r here in this way. So let me shift r bar in this way. So this is your r bar and v bar. They will be perpendicular to each other. But now if I do cross product, the direction of cross product will be perpendicular to both the vectors. So if I follow right hand rule, I will keep the fingers like this. It's a scary finger, I know, but this is how it will be. And then you will curl them towards v bar. So direction will be perpendicular to both r bar and v bar. This is going to be direction of angular momentum, perpendicular to both r bar and v bar. Now this direction, if I show here in this diagram, it will be directed like this. Now as the particle moves, that angular momentum direction vector will keep on changing. That angular momentum direction vector will keep on changing. Suppose this is the cone, this is the rod, and this is the angular momentum vector. Now as the body rotates, angular momentum magnitude is same, but look at the direction. My finger is indicating the direction. Direction will keep on changing. So as the direction changes, vector is changed. So to say momentum vector is constant, we have to have same magnitude as well as same direction. Here magnitude is same, but direction is changing. So we don't have such option where magnitude is constant but direction is changing. Such option is not there for B. Okay, there's only one correct answer here, which is option D, where A has constant magnitude as well as constant direction, which is along the axis, Z axis. Okay, for B, magnitude is constant, okay, but direction is not constant. Okay, thank you. Hello. So two superbubbles of radii A and B more than A, stick to each other. Radius of curvature of common surface is, and answer is in terms of A into B upon B minus A plus B upon A into B, and so on. So here we know that for a drop or for bubble, because of the surface tension, pressure inside is always more than pressure outside, and that excess pressure formula is delta P equal to 4T by R. So excess pressure is inversely proportional to R. So here you can see that radius of bubble B, the bubble having radius B, is more than that of A. So excess pressure for bubble B will be less than excess pressure for bubble A. So here when I'm writing for bubble, excess pressure for bubble A, bubble B, outside pressure will be same for both of them. So if I draw two bubbles separately, suppose this is bubble B having radius, radius is B, and this is a smaller bubble having radius A. So pressure inside will be PA, outside pressure PO, and for bubble B, pressure inside will be PB. So outside pressure is same for both of them. So we can conclude that outside pressure is same, inside pressure or the difference in the pressure is more for A as compared to B. So we can say inside pressure of A is more than inside pressure of B. Okay. So when this is our main conclusion, inside pressure of A is more than that of B. Smaller radius, higher excess pressure. So now when these two bubbles will touch each other, they will have a common surface. Now even that common surface will have a curvature because of the pressure difference on both sides. That curvature will become flat if both sides had same pressure. But now both one side has pressure PF, the other side will have pressure PB. And because of the pressure difference, there will be curvature on the common surface as well. So if I visualize that, it will be something like this. This is one bubble and this is the other bubble. They're touching each other and the common curvature is, let's say, this part. Okay, this is pressure PA, this is pressure PB, and what we have to solve for is radius of curvature of this curve. Now remember, this curve is of radius small r, the common curvature. Okay, that is different from A. What is going to be the radius of this curvature? Now that curvature shape can be anything. It can be a curve like this, okay, or it could be a curve like this. We don't know the exact shape. We have to figure that out, exact radius. So for this particular common surface, we can use pressure difference formula. Pressure on the concave side is always higher. A side has higher pressure. So pressure at point A, or pressure on the A side minus pressure on the B side, will be equal to 4T by small r. Okay. So our goal is to find out this small r value. Correct. So to get this value, what we will do, we will write down same excess pressure formula for bubble B as well as for bubble A. So for bubble B, inside pressure PB, outside pressure PO, that is equal to 4T by B. So for bubble A also we can write down the same, inside pressure PA, outside pressure is PO, outside pressure PO equal to 4T by A. Now we have two equations. We can subtract these two equations. So equation number 1 and equation number 2. Let's subtract them. So if you subtract 2 minus 1, we'll do 2 minus 1. So 2 minus 1. So on the left hand side we will have PA minus PB. Here 4T will be taken common. And we have 1 by A minus 1 by B. So this equation's left hand side and this equation's left hand side is same to same. Okay, so we can equate these two left hand side. Okay, so if I use these two equations, I will complete the rest of the calculation here. So left hand side is same, right hand side is also same. So we can write 4T upon R equal to 4T upon 1 by A minus 1 by B. Okay, so 4T and 4T cancel, cross multiply this and do reciprocal. So if you do cross multiplication and then reciprocal, answer for A will be AB upon B minus A, and this is our final answer. Okay, AB upon B minus A. So AB upon B minus A, that means correct answer here is option A. Thank you. Hello. Given below are two statements, statement 1, statement 2. Truck and car moving with same kinetic energy are brought to rest by applying brakes which provide equal retarding force. Both come to rest in equal distance, that is statement 1. Statement 2 is car moving towards east takes a turn and move towards north. The speed remains unchanged. Acceleration of the car is 0. In the light of the above given statements, choose the most appropriate answer from the options given below. So which one is correct, which one is incorrect, both are incorrect, both are correct, that we have to figure out. So statement 1, let's read that again. A truck and a car moving with the same kinetic energy. So they have same kinetic energy and brought to rest by applying brakes which provides equal retarding force. So in both the cases, both the vehicles are getting equal retarding force. So both will come to rest in the equal distance. So here we can take help of work energy theorem. To solve this, we can take help of work energy theorem. Work done by the retarding force, work done by the force applied by brakes will be opposite to the displacement. That work done will be equal to force multiplied by displacement, but negative, because the force of brakes and the displacement are in the opposite direction, so work done will be negative. Now this work done is also equal to change in kinetic energy, that is work energy theorem. So we are calculating work done by the retarding force, the force which is opposing the motion, trying to stop it. That force work done will be force multiplied by displacement, but this work done will be negative. Work done formula is F S cos of theta, where theta is angle between two vectors, which in this case it is going to be 180, because force and displacement are in the opposite direction. So here work done will be negative, and this work done is equal to change in kinetic energy. So change in kinetic energy will be final kinetic energy 0 minus initial kinetic energy K initial. Finally both of them will stop, so final kinetic energy 0. So from here if I calculate displacement, then displacement is equal to initial kinetic energy upon retarding force. So both the vehicles have same initial kinetic energy, both the vehicles have same decelerating force, same retarding force, so displacement will also be same. Stopping distance, the distance in which both of the vehicles will stop, will also be same. So statement 1 is definitely correct. Okay, now let's read statement 2. A car is moving towards east, makes a U-turn, makes a turn and move towards north with the same speed. So initially car is moving towards east. So let's say this is the initial velocity, moving towards east. Okay, and now the car makes a turn and move towards north. So this is how car is moving towards north. Let's say initial velocity is v1 bar, final velocity is v2 bar. Now the magnitude is same. So if we assume magnitude is v, so this can be written as v into I cap, and this can be written as v into j cap. So in this case acceleration of the car is 0, which is absolutely wrong. Acceleration is change in velocity with respect to time. Is velocity changing? Yes. Acceleration is change in velocity, not change in speed, change in velocity. So velocity is a vector quantity. It has magnitude as well as direction. Here magnitude is same, but direction is changing. So velocity vector is still changing. In a vector, if only magnitude changes, direction same, then the vector is changed. Or if magnitude is same and only direction changes, then also vector is changed vector. Or if both of them are changing, then of course it is a changed vector. So here magnitude is same but direction is changing. So there is change in velocity vector, divided by time will give you acceleration. So acceleration is not 0 in this case. So statement 2 is wrong. So statement 1 is correct and statement 2 is wrong. So statement 1 correct, statement 2 is incorrect. So correct option is A. Thank you. Hello. For a certain organ pipe, first 3 resonance frequencies are in ratio of 1:3:5 respectively. If the frequency of the 5th harmonic is 405 Hz and speed of the sound is 324 meter per second, length of the organ pipe is dash meter. So now, by the first part of the statement in the question, it is mentioned as a certain organ pipe, but its first 3 resonance frequencies are in the ratio of 1:3:5, which means if the first frequency, fundamental frequency is 1, the next frequency is 3 times the fundamental frequency. Then the frequency after that is 5 times the fundamental frequency. So you can notice that only as per the given pattern 1:3:5, only odd harmonics are present. Only odd harmonics are present. Now odd harmonics, that means it's a clear indicator that this is closed organ pipe. Okay, so this is closed pipe, and for closed pipe we have the frequency of the 5th harmonic. Now 5th harmonic means 5 times fundamental frequency of closed pipe. 5th harmonic means 5 times fundamental frequency, and this frequency is given as 405. Now fundamental frequency for a closed pipe, formula for fundamental frequency of a closed pipe is V by 4L, where L is length of that closed pipe. Let me write as LC equal to 405. So we can divide this. So this will be 81, and V value is 324 upon L into length of closed pipe equal to 81. Now this 81 multiplied by 4. Okay, so this is perfect 324 only. So this and this cancel 1. So answer is 1 meter. So that's it. That is the final answer. Length of the closed organ pipe is 1 meter. Thank you. Hello. Two plates A and B have thermal conductivities of 84 watt per meter per Kelvin and 126 watt per meter per Kelvin respectively. They have same surface area and same thickness. They are placed in contact along with their surfaces. If the temperature of the outer surface of A and B are kept at 100 degrees Celsius and 0 degrees Celsius respectively, then the temperature of the surface of the contact in steady state is dash degrees Celsius. So first you have to visualize this. There are two plates and their thermal conductivity is given. So heat current can flow through these conductors, and they are placed so that their surface is in contact, and one side, let's say side of A is maintained at 100 degrees Celsius and that of B is maintained at 0 degrees Celsius. So heat current will flow from high to low, and in this case what is the current of the interface where both the materials will come in contact, that temperature we have to figure out. So we can visualize this. So let's say this is plate A and then there is plate B. Their thermal conductivities, I'm writing just K1 and K2. So let's say this is K1 value and this is K2 value. Now they have same surface area. So surface area is something which is not directly visible in the diagram. If we draw it in 3D, then we'll see the surface area. This is going to be the surface area, like this. This is the surface area that will be same for both the materials, for both the plates. And their thickness is also same. So thickness is which dimension? Thickness is this dimension. Let's call it as T each. Fine. Now question says that there is temperature of the plate A, so the one having thermal conductivity K1. Okay, so this is K1 and this is K2. So I will write their name. This is plate A and this is plate B. Plate A temperature, okay, the outer surface of A, which is the left hand side, that is maintained at 100 degrees Celsius, okay, and right hand side of B, that is maintained at 0 degrees Celsius. So heat current always flow from high to low. So heat current will flow in this direction, from high temperature to low temperature, from high temperature to low temperature. Okay. So this is which combination? First of all, we have to identify this is conduction mode of heat transfer, but via which combination? So your heat current is passing through the interface, passing through the boundary. So this is series combination of, yes, this is series combination of the thermal resistance or thermal conductors. And in series combination, we know that current will remain same, which is similar to our regular electrical current as well, and electrical series parallel combination as well. Current will remain same. Here heat current will remain same. And with this information, we have to find out what is the temperature of the interface. So let's say the temperature of the interface is X degrees Celsius and heat current will be same. What is formula for heat current? Let me write down formula for heat current. Heat current is equal to K A delta T upon L. Okay, in this formula, H is heat current, heat energy flowing per unit time, K is thermal conductivity, A is area of the cross section, delta T is the difference between high temperature and low temperature, L is the length of the conductor. Okay, so here I can say heat current in the left hand side is H1 in the K1 material, heat current on the right hand side is H2 in the K2 material, and since they are in series combination, so heat current will be same, H1 will be equal to H2. Now heat current formula, which is this formula, we will use it for H1, where thermal conductivity is K1, area A, and temperature difference will be high temperature minus low temperature. So 100 degree is at high temperature minus x degree, that will be low temperature, divided by length. Here length will be the T dimension, which is same for both of them. Same heat current equation we can write down for the second material. In second material, heat is traveling from x degree Celsius to 0 degree Celsius. Thermal conductivity is K2, area is A, and high temperature will be x minus low temperature 0. Okay, here x will be at the high temperature, heat flows from high to low. And length of the conductor will be T. I am assuming letter T here, which is thickness for both the slabs, which will be same given in the question. Area is also same given in the question. So we can cancel area from both the sides, thickness from both the sides, and substitute the values that we know. So K1 value is 84 into 100 minus x, and K2 value is 126 into x. Okay, now we can divide by 6. We can divide by 6. Let's see, if I divide by 6, this will be 2, and 121. If I divide by 6 here, this will be 1 and 4. Okay, so we can further divide by 7 as well. So this will be 2 and this is 3. Now open the bracket. So if I open the bracket at this stage, this will be 200 minus 2x equal to 3 times x. So 200 will be equal to 5x. So solve this, x will be equal to 200 by 5, that is 40. Answer is 40 degree Celsius. Temperature of the interface will be 40 degrees Celsius. Okay, so the key idea here is to identify the given arrangement is a series combination, and for series combination, heat current will be same. So write heat current equation for through K1 material and through K2 material, equate these two equations, and that will give you the unknown interface of the temperature of the interface. Okay, thank you. Hello. An insulated copper wire of 100 turns is wrapped around a wooden cylindrical core of cross-section area 24 centimeter square. Two ends of the wire are connected to a resistor. Total resistance of the circuit is 12 ohm. If an external applied uniform magnetic field in the core along its axis changes from 1.5 Tesla in one direction to 1.5 Tesla in the opposite direction, charge flowing through a point in the circuit during the change of the magnetic field will be dash millicoulomb. Now, when magnetic field will change its direction from one side to the other side, flux associated with this coil will change. Now, if you visualize, this is the wooden cylindrical core over which this is how the coil is wrapped, and we are connecting an external resistance here. Total resistance of the circuit is given as 12 ohm. And magnetic field direction is changed from along the direction of axis in one direction to other direction. So let's say initially magnetic field was directed like this, and then magnetic field was changed, and then the magnitude is same. You can see that 1.5 Tesla, 1.5 Tesla. but the direction is changed. So in this process, how much charge is flowing through the coil? Now this is a case in which magnetic field is changing, so flux associated with the coil will change, and whenever there is a change in flux associated with the closed loop, current will induced, MF will be induced, current will start to flow. Now how much charge will flow? Because of that, we know standard formula for charge flowing in the circuit, that will be delta Q equal to delta 5 minus of delta 5 divided by resistance R. So delta phi minus of delta phi, final flux is phi 2, initial flux is phi 1, divided by R is resistance, and delta Q is the charge flowing through the loop. Now flux here will be obtained, flux formula is N into B into A into cos of theta. So here flux in the second case is N into B into A cos of 180 minus N into B into A into cos of 0. So assuming initially area vector and magnetic field vector are in the same direction. So if I show the area vector in this diagram, this is how the area vector will be. So initially magnetic field and area vector both are in the same direction, so angle between them is 0. So NBA cos of 0, this is your initial flux. N number of turns in the coil, B is magnetic field, A is area of the coil, and theta is the angle between area vector and magnetic field vector, which will be 0 initially, and then its magnitude is kept same but the direction is changed. So then B1 will be changed to same magnitude but opposite direction. Now look at the direction of B2 and area. Area vector and B2 both are in opposite direction in this case, so angle between them will be 180. So in the second case, angle will become 180. Number of turns same, magnetic field magnitude is same, area is same, only angle is changed. Okay. So now we can complete the calculation. This whole thing divided by resistance. So whatever we can take common, we will take it common. So this will be NBA common, cos of 180 minus 1 cos 0 1 whole divided by resistance R. Okay. Now we can continue the calculation here. So this will become minus minus plus 2 into NBA upon R. Now it's time to substitute all the values that we know. So 2 into number of turns are 100. So 10 raised to 2 into magnetic field 1.5 into area is 24, but remember that 24 is in centimeter square. So conversion I'm writing here 24 into 10 raised to minus 4 centimeter square to meter square conversion, and this whole thing divided by resistance, that is 12. Okay. Now we can complete the calculation here. This will be 12 and 24 cancel. This is 2. This is 2 into 2, 4 into 1.5. So 4 into 1.5, that will be 6. Then 10 raised to 2 and 10 raised to minus 4, that will be 10 raised to minus 2. 6 multiplied by 10 raised to minus 2. So this is answer in coulomb. Everything in SI unit, answer will be also in SI unit. But option we have to present in millicoulomb. So we'll adjust this. We just have to adjust this as 60 into 10 raised to minus 3. Okay. So adjusting this as 60 into 10 raised to minus 3. 10 raised to minus 3 is millicoulomb. So answer is 60 millicoulomb. Okay. So final answer is 60 for this particular question. Okay. So this is the standard formula that we have to keep in mind. Cool. Thank you. Hello. As shown in the figure, The plane mirror is fixed at an height of 50 centimeter from the bottom of the tank containing water. Refractive index of water is mentioned 4 by 3. Height of water in the tank is 8 centimeter. You can see that in the diagram. A small bulb is placed at the bottom of the water tank. Distance of the image of the bulb formed by the mirror from the bottom of the tank is dash centimeter. Distance of the image of the bulb formed by the mirror from the bottom of the tank is how much? So here, where is the object? So notice carefully where the object is. Object is here. It's a point source of light at the base of the container. Now light will emerge out from that source, will pass from water into air. So it will refract, and that refracted light ray will fall on the mirror. So if I draw ray diagram here, then let's say this is the container. This is the container. And this is water. Okay, up to 8 centimeter. So light will start like this, like this. It is going from water into air, so it will bend away from the normal. It will bend away from the normal, so it will refract like this, refract like this. And if I extend those refracted rays, then this is where the intersection will be. So this is real depth, that is 8 centimeter. But for somebody who is observing this from outside, for that observer, depth will appear this much only. Now that is the apparent depth. We can calculate that apparent depth. Let's say apparent depth is h dash. And now we have formula for apparent depth. H dash is equal to mu observer into h by mu. H dash is the apparent depth. Mu observer is the refractive index of the medium in which observer will be present. So here observer will be somebody who is outside the container observing from the top. So that is going to be 1. H is the real depth. Real depth is 8 centimeter divided by refractive index of that medium in which the real depth is measured. That is 8 centimeter measured in water. So water's refractive index 4 by 3. So real depth is 6 centimeters. Right? Real depth is 6 centimeters. So we have answer for H dash, apparent depth. Now this refracted light ray will fall on the mirror. This refracted light ray will fall on the mirror. And suppose this is how the container is, and mirror is placed here. So from the point of view of mirror, this is the object. Okay, if you notice carefully, these light rays over which I'm drawing arrow right now, these light rays. Okay, so these light rays are incident rays for the mirror, and intersection of incident ray will give you object. So from the mirror point of view, image formed by the refraction will act as a object. These are refracted rays. These rays are refracted rays. So they will give you image from the refraction point of view, but they are incident rays for the mirror. So they will give you object. So this apparent position of the source will behave like an object for the mirror, and mirror will form the image. And for mirror, we know for plane mirror, object distance is equal to image distance. Exactly. So object distance will be this 6 centimeter. That means from the bottom we can remove 2 centimeter. If I measure distance from the bottom, this distance from the bottom, 8 centimeter minus 6 centimeter, that will be 2 centimeter. So if I study only for the mirror, then for the mirror, object distance is total 50 centimeter from mirror to the base of the container. This is 50, right? So 50 minus 2, 48. So that is the distance of the object from the mirror point of view. So if the object distance is 48, if this object distance is 48, then same will be the image distance 48 for a plane mirror. Object distance is equal to image distance. So if object distance is 48, image distance will also be 48. So distance of the image from the mirror will be 48 centimeter. Okay. Actual object is here, but for the plane mirror, refracted rays will fall on it, not the actual light rays originating from the light source. So those refracted light rays intersection will give you object from the point of view of mirror. So that object is at a distance of 2 centimeter above the ground, above the base of the container. So from the total 50, we remove 2 centimeter, 48. If 48 is the object distance, this is 48 object distance. So same will be image distance. If object distance is 48, image distance is also 48. Now we have to get the distance of this image from the bottom of the tank. From the bottom of the tank. So total distance will be 48 till the mirror, and from the mirror to the bottom of the tank 50. So total distance will be 50 plus 48 centimeter. Okay, so 98 centimeter is the final answer. Okay, so this is your final answer, 98 centimeters. Thank you. Hello. An unpolarized beam of light is incident on the first polarizer of polarization experiment containing two parallel polarizers, and the maximum intensity of the light beam emerging from the second polarizer is measured as 100 lumens. Now, if the second polarizer is rotated around the horizontal axis, that is basically direction of light, by 30 degree in clockwise direction, intensity of the emerging light will be dash lumens. So in the first case, unpolarized light, so let's say this is unpolarized light, passes through first Polaroid and it will get polarized. So after an unpolarized light gets polarized, intensity will be directly half. So whatever the intensity is, it will become half after polarization. And then there is a second Polaroid, and here the intensity that we get to the second Polaroid is maximum, and that is 100. So the second Polaroid must be parallel to the first Polaroid. So it should be placed like this. Then as per Malu's law, the output here after the second Polaroid will be I naught by 2, that is the input, times cos square theta, where theta value should be 0 if you want maximum intensity. So angle between first Polaroid and the second Polaroid will be 0. Then the output intensity through second Polaroid will be maximum. And this intensity is given as 100. So we have the I naught value, that is 200 lumens. Now the question says, if you change this orientation, the first Polaroid will remain same, no change in the first Polaroid, that will remain as it is. Now the second Polaroid is tilted like this, and the angle that it makes, or the angle that by which we are rotating it, it is 30 degree. So it was unpolarized light to begin with, that will still get polarized by the first Polaroid. There is no change in the first Polaroid. So light will get polarized and intensity will become half here. Okay, original light intensity is same. After first Polaroid will become half. And now as per Malu's law, the output intensity will be input times cos square theta. Here theta will be 30 degree. Theta in Malu's law stands for angle between angle of the current pass axis of the Polaroid and the pass axis of the previous Polaroid. Okay, and this angle is 30 degree in this case. What is the intensity in this context? So we can simplify this. Now we just have to put the value of I naught here. I naught value is 200 divided by 2 into cos square 30. Cos 30 root 3 by 2, square will be 3 by 4. Okay, so this will be 100 and for the calculation we'll give you final answer as 75 lumens. Okay, so final answer for this particular question is 75 lumens. Thank you.
Hi everyone. In this question, we are given four options with two pairs of ionic compounds each, and we have to find out the correct set in which the pairs are written in the correct order of their melting points. So melting points basically are directly proportional to the magnitude of attractive forces between the positive ion and the negative ion in an ionic solid. The one pair that they have given is lithium fluoride and lithium chloride, LiF and LiCl, because the ionic charges are same. So now we will look at ionic character. In lithium fluoride, there is higher ionic character because fluoride ion is smaller compared to chloride and hence it is less polarizable. Whereas in lithium chloride, because of the large size of chloride ion, there is significant polarization by lithium of chloride ion and there is some amount of covalent character which actually decreases the melting point. So out of LiF and LiCl, lithium fluoride will have higher amount of ionic character and higher melting point. Out of NaCl and magnesium oxide, there is basic difference of charge. So first we will look at the magnitude of charges. In sodium chloride, the charges on each cation and anion is 1 unit, whereas in MgO, the charge on cation is +2 and the charge on anion is -2. So because of the higher charges on cation and anion in magnesium oxide compared to NaCl, the electrostatic force of attraction is stronger, and because of which the melting point is higher for magnesium oxide. So out of LiF and LiCl, lithium fluoride will have higher melting point, and out of NaCl and MgO will have higher melting point. So that only matches in option D. Out of LiF and LiCl, LiF has higher melting point, correct? And out of MgO and NaCl, MgO has higher melting point. So that is the correct answer in this. Thank you. Hi everyone. In this question, we are given a metal chloride and we have to find out the molecular formula of the compound given the information. This question is based on mole concept. The concepts are simple, just the calculation might be a little bit tricky. The metal chloride contains 55% of chlorine by weight. So whatever is the molar mass of the metal chloride, out of that 55% by weight will be chlorine. It is also given that 100 ml of the vapor of the compound at STP weighs 0.57 gram. So if we take 100 ml of the vapor, the mass of that vapor will be 0.57 gram. We can apply this information with unitary method and find out what is the molar mass of the compound. It is given in the question that molar volume of an ideal gas at STP is 22.7 liter. So let us use this information. 100 ml of the vapor has mass 0.57 gram. So if we take 1 mole of the compound, which will have a volume of 22.7 liter, in terms of milliliter, this would be 22,700 ml. So the equivalent mass would be 0.57 divided by 100 multiplied by 22700, right? So this comes out to be 0.57 multiplied by 227 gram. So this is your molar mass of the compound. Now they have said the compound contains 55% chlorine by weight. So what is the mass of chlorine in this compound? So that is 55%, which is 55 by 100 multiplied by 0.57 multiplied by 227 gram. So this comes out to be 0.55 multiplied by 0.57 multiplied by 227 gram. This is the mass of chlorine in 1 mole of compound. To determine the molecular formula, it is just sufficient to find out how many chlorine atoms are present in one formula unit of the compound. So if there is one chlorine, the answer would be option A, MCl. If there are two chlorine atoms per molecule of the compound, the answer would be MCl2 and so on. So we just need to find out the number of moles of chloride. present in 1 mole of the compound. To find out the number of moles of chloride, we'll divide this mass by the atomic mass of chlorine, which is 35.5. So now we are going to divide this number 0.55 into 0.57 into 227 divided by 35.5. Now this might seem like a very ugly calculation, but you also observe that the answer has to be an integer. As per the options, the answer this calculation has to be equal to either 1, 2, 3, and 4, right? So we can do this calculation, and 0.55 into 0.57 will be approximately 0.3, and 0.3 into 227 will be approximately somewhere around like 70. So that number divided by 35.5, we can say with confidence that it would be 2. So there are 2 chlorine atoms per molecule of the compound. So the correct answer to this question would be MCl2. Thank you. Hi everyone, this question is from biomolecules, specifically the carbohydrate section. There are 2 lists in this question. List 1 contains 3 disaccharides, sucrose, lactose, and maltose, whereas list 2 contains some monosaccharides, and we have to match each disaccharide with its constituent monosaccharide. So if you take sucrose, a very common disaccharide, it consists of 1 unit of alpha D glucose and 1 unit of beta D fructose with C1 C2 linkage, and hence sucrose is a non-reducing sugar because C1 of glucose, which is carbonyl, and C2 of fructose, which is also carbonyl, they are joined together by a glycosidic linkage, leaving behind no possibility of a free carbonyl group upon hydrolysis, and hence sucrose is a non-reducing sugar. So sucrose is a disaccharide consisting of alpha D glucose and beta D fructose. So A matches with second. So, well, that itself gives you the correct answer as option D. But anyway, let's see the remaining ones. Lactose is a disaccharide consisting of beta D galactose and beta D glucose with a C1 C4 linkage. So lactose is a reducing disaccharide. Maltose consists of 2 units of glucose, right? So maltose again has C1C4 linkage. So in one of the glucose units, the carbonyl group can be set free, and hence maltose is a reducing sugar. The correct answer to this question is option D. A matches with second, B matches with first, and C matches with third. Thank you. Hi everyone. This question is about the inorganic qualitative analysis, where we are given a few reactions and we have to identify on the basis of those reactions which of the following salts could be the correct answer. Let's read the question. There is an inorganic compound X which on treatment with concentrated H2SO4 produces brown fumes and gives dark brown ring with ferrous sulfate in presence of concentrated H2SO4. So this is the classic, very famous brown ring test that is given by nitrite ion, right? Because the acid is concentrated H2SO4, this would be nitrite ion. Nitrite ion also responds with dilute acids because that reacts more easily, more rapidly. So the anion is nitrate, which produces brown fumes of NO2 on reaction with H2SO4 and with freshly prepared ferrous sulfate, and then on addition of H2SO4 from the sides of the test tube, we get this compound FeH2O5 NO2 plus, which is responsible for the chocolate or woody brown color of the brown ring. So that is nitrate. This rules out option B as the correct answer. Now the compound X also gives a precipitate Y when it is treated with dilute HCl in presence of H2S gas. So now coming to the cationic tests, dilute HCl and dilute H2S is a group reagent for group 2, and cobalt is definitely not in group 2. It is in group 4. So either copper or lead could be the correct option here. For that, let us read the question further. The precipitate Y on treatment with concentrated HNO3 followed by excess of ammonium hydroxide gives deep blue color. So that is definitely our copper, because when you have copper sulfide on treatment with HNO3, it converts to copper nitrate, and then copper nitrate on reaction with ammonium hydroxide, which provides ammonia ligand, it gives us a bright blue colored compound tetramine copper, which is this. So the correct answer to this question is copper nitrate. Thank you. Hi everyone. In this question, we are given four carbocations and we have to find out of these four carbocations which ones are resonance stabilized. So resonance is a type of electron displacement effect that involves delocalization of pi electrons and or lone pairs. So the very simple trick to find out which of these carbocations have resonance in them is to ascertain that the positive charge is adjacent to a pi bond, because all of these have pi bonds and positive charge both. So for example, in the first carbocation, the carbocation is benzyl and we have a benzene ring, and next to benzene ring, we have a positive charge. So here resonance can occur, right? For example, this pi electron pair of benzene ring can shift here, and this could be the next resonating structure. All right. So that is how we have drawn like one resonating structure, and this positive charge can move, along the ring further by the movement of pi bond, right? So cation A is resonance stabilized, that is benzyl cation. So that rules out option A as the correct answer. Moving to option B, again, you can see that the positive charge is adjacent next to a pi bond. So you can shift this pi bond here, right? So the next resonating structure would be HH, then the positive charge would migrate here on this carbon, and this would be your double bond. So the carbocation B is also resonance stabilized. Okay, now coming to carbocation C, we can see that the pi bond and the positive charge, they are separated by a saturated carbon, which is sp3. Now, whenever you have this situation, resonance cannot occur because sp3 hybridized carbon does not have any orbital available, like to participate in conjugation. So there is no resonance in carbocation C. In carbocation D, again, the positive charge is not in conjugation with the carbonyl group because they are separated not by one but by two sp3 hybridized carbon atoms. So because of these saturated carbon atoms, the pi electron pair and the positive charge cannot be in conjugation with each other. Okay, so the carbocation C and D, they are not resonance stabilized, whereas carbocations A and B are. So the correct answer to this question would be option C. Thank you. Hi everyone. This question is based on the bonding theories, where we are given four species and we have to find out the species that contains one pi bond and maximum number of canonical forms, that is resonance structure. So the given species are SO3, O2, SO2 and CO32 minus. Sulfur trioxide, if we draw its Lewis dot structure, so it can have three pi bonds. So that rules out is as one of the option because we only have to consider the species with one pi bond. So that is out. O2 has one pi bond indeed, but obviously it does not have any other stable resonance structures, whereas we can draw more for SO2 and carbonate ion. SO2 has one pi bond in one of the structures we can draw, like in the Lewis dot structure, we can draw one pi bond like this. But then it will have only two resonating structures because the pi bond can be either on the left hand side sulfur oxygen bond or it could be on the right hand side sulfur oxygen bond. So leading to a total of two resonance structures. In carbonate ion, again, we have one pi bond. If we look at the Lewis dot structure, right? But the total number of resonance structures, that is three, because this pi bond can either be on this oxygen on the top, on this oxygen on the left hand side, or on this oxygen on the right hand side. For instance, we can have the double bond here, then the other two oxygen atoms would have negative charge, and similarly we can have the pi bond on the right hand side oxygen. So carbonate ion satisfies both the conditions of one pi bond and maximum, that is three resonance structures. So the correct answer is carbonate ion. Thank you. Hi everyone, this question is based on the integrated rate equation from the chapter Chemical Kinetics. Here we are given an elementary chemical reaction and we have to find out the expression for dA by dt. So for this chemical reaction, we can write the rate as minus dA2 divided by dt, and we can also write rate law, a rate in terms of the concentration of product as 1 upon 2 dA by dt. So this is the instantaneous rate in terms of the derivative, but we can also write the instantaneous rate of reaction as rate law. So which is equal to the rate of consumption of reactant, so which is K1 A2, and minus the rate of formation of the reactant, which is basically minus K inverse A and raised to the power 2, because we are assuming the reaction to be elementary. Now we can see that these two rates are equal to each other, which means that this term is also equal. So we can write from here that half of dA by dt is equal to K1 A2 minus K inverse A square, and taking this coefficient 2 on the right hand side, we can see that the rate of change of concentration of A is equal to 2 K1 A2 minus K inverse multiplied by 2, right? And A square, right? So the correct answer for this question would be 2 K1 A2 minus 2 K inverse A square. That is option D. Thank you. Hi everyone. This question is from isomerism of coordination compounds, and in this question we have to find out the total number of isomers for a square planar complex of the formula M, where M is a central metal atom, fluoride is one ligand, chloride is one ligand, SCN minus is one ligand, and NO2 minus is the fourth ligand here. So we have to find out the total number of isomers. So because this is a square planar complex, right, and there is no chirality here, so optical isomerism will not be possible. So we are talking about geometrical isomerism here. Now for a square planar complex containing 4 different type of ligands, the total number of geometrical isomers otherwise is 3. That is, if there is no ambidentate ligand present, if there is no such ligand present which has more than one type of donor atom, which is a case here actually, because in SCN minus, the ligand can bind to the central metal atom either through sulfur or through nitrogen, and same is the case with NO2. The donor atom can be nitrogen as well as oxygen. Now, ignoring the fact that there are ambidentate ligand, let us first see what are the 3 original geometrical isomers. So this is like the central metal atom, and these are 4 positions in a square planar complex. Let us fix the position of one ligand, let's say fluorine. We do not have to change the position of this ligand. All right. Now, trans to fluoride ligand, we can either put chlorine, we can either put SCN, or we can either put NO2. All right. So the remaining 2 ligands will occupy the remaining 2 positions. For example, in the first complex, FCl are assigned. So I can put SCN here and NO2 here. In the second complex, fluorine and SCN are already assigned positions. So I can put chlorine here and NO2 here. And in the third complex, fluorine and NO2 are assigned positions. So I can put chlorine here and SCN here. Okay. So now there are 3 geometrical isomers. You can randomly choose any 2 ligands out of these 4. So for example, let us pick fluorine and chlorine. So you can observe that in the first complex, fluoride and chloride, they are trans with respect to each other. In the second complex, fluoride and chloride are cis with respect to each other. And in the third complex also, fluoride and chloride are cis with respect to each other. So which is cis, which is trans, that is arbitrary. But generally speaking, there would be 2 cis isomers and 1 trans isomers. That is the story if there is no ambidentate ligand. But this complex has not just 1 but 2 ambidentate ligands. As I said, one is thiocyanate and another is nitrito. So which means that the Thiocyanate can actually bind through two donor atoms, sulfur and nitrogen, and same is the case with NO2. So what are the total combinations here? So that would be 4, right? Because SCN can bind through either sulfur or nitrogen, and NO2 can bind through either nitrogen or oxygen. So there would be 4 possibilities in this and 4 possibilities in this. So the total number of possibilities that would be there in this complex would be 12. So the total number of geometrical isomers possible for this complex would be 12. That is your correct answer. Thank you. Hi everyone, this is a statement-based question from the chapter DNF block elements, specifically from lanthanoids because cerium is a lanthanoid. Given below are two statements. Statement 1 says that the E naught value, which is a standard reduction potential value for cerium 4 plus slash cerium 3 plus redox couple is 1.74 volt. Now this is something that is experimental. So this is a statement from the NCERT textbook. So if you remember it, you would know, yes, this statement is correct. The E naught value for cerium 4 plus 3 plus redox couple is approximately 1.74 volt. This clearly indicates that the high reduction potential means the species prefers to stay in the reduced form, which means that out of 4 plus and 3 plus, cerium is more stable in plus T state. This is in fact true for all lanthanoids. Their plus 3 state is generally the most stable one. Now the statement 2 says that cerium is more stable in plus 4 state than plus T state. This is of course incorrect. A high reduction potential means the species is more stable in the reduced form. So cerium 4 plus is actually less stable compared to cerium 3 plus state. So cerium is more stable in plus 4 state. That is an incorrect statement. So statement 2 is incorrect, whereas a statement 1 is correct, right? So statement 1 is correct, but statement 2 is incorrect. So option B is the correct answer. Thank you. Hi everyone. This question is based on the general properties of group 15 elements. A group 15 element which is a metal and forms a hydride with the strongest reducing power among all the group 15 hydrides. So we have to tell that which element they are talking about. So this single word gives the answer away because they have said a group 15 element which is a metal. Now if you look at these, arsenic, antimony, bismuth and phosphorus, right? Of course, the only metal among these elements is bismuth. Anyway, we know that as we move down the group, because of the decrease in the element hydrogen bond enthalpy, the bond breaks easily. Hydrogen can be set free relatively easily, and as a result, the molecules become better hydride donors as we move down the group, which translates to greater reducing power. So the only metal, of course, is bismuth, and yes, it has the strongest reducing power because it has the weakest element hydrogen bond. So the correct answer in this question is option C. Thank you. Hi everyone, this is a statement based question in which we have to tell that either both statements are correct, both statements are incorrect, or which one of them is correct and the which one is incorrect. Statement 1 says that in redox titration, the indicators used are sensitive to change in pH of the solution. So this is basically based on volumetric analysis, different types of titrations. So to understand this, we need to know what is an indicator. An indicator is a substance that marks the endpoint in a titration, generally by a color change. Okay, so in redox titration, the indicators used are sensitive to not to the change in pH but to the change in potential, because in redox titration, as the reaction proceeds, the potential of the system changes, and there is a point when the reaction is complete, then indicator changes color because of the sudden change in potential. So this statement is incorrect. The statement 2 says that in acid-base titration, the indicators used are sensitive to change in oxidation potential. Now, this is again incorrect because in acid-base titration, the indicator is generally a weak acid or weak base, depending upon our substances that we are titrating with. So indicator is a weak acid or a weak base that undergoes ionization when the reaction is complete and thereby changes color and marks the endpoint. So in acid-base titration, the indicator is sensitive to change in pH and not to the change in oxidation potential. So this statement is also incorrect. So the correct statement is The correct answer is both statement 1 and statement 2 are incorrect, hence the option B. Thank you. Hi everyone. In this question, we are given 4 statements about lead storage battery and we have to select the correct statements. First statement is during charging of battery, lead sulfate on anode is converted to lead dioxide. So one thing we need to remember is that in the lead storage battery, during discharging, lead is converted to lead sulfate on anode, and on cathode, lead dioxide is reduced to lead sulfate. So these are the reactions, main reactions happening at anode and cathode during discharging. But when the battery is charged, current is applied in the opposite direction. The polarities of the electrodes are reversed. Now the electrode, which was earlier acting as anode, now it will start acting as cathode. And the electrode, which was earlier acting as cathode, now it will start acting as anode. Which means that in lead storage battery, during discharging, these reactions are happening, and during charging on anode, lead sulfate is oxidized back to lead dioxide. So statement 1 says that during charging of battery, lead sulfate on anode is converted to lead dioxide. Yes, this statement is correct. On cathode, lead sulfate is reduced back to the elemental form of the metal. So obviously option B, which says that during charging of battery, lead sulfate on cathode is converted to lead dioxide, this is incorrect. Coming to option C, lead storage battery consists of grid of lead packed with lead dioxide as anode. This is incorrect because we have seen that in lead storage battery, anode is lead electrode, right? It is the cathode that is grid of lead packed with lead dioxide. So statement C is incorrect. Coming to the last statement, the battery also has 38% solution of sulfuric acid as an electrolyte. So that is correct. That is factual. The electrolyte in lead storage battery is approximately 38% solution of sulfuric acid, right? So that provides, ions in the electrolyte. So statement D is correct here. So in this question, statement A and D are correct, and hence the correct answer is option C. Thank you. Hi everyone, this question is based on the colligative properties, specifically the depression and freezing point. Now we know that when we add a non-volatile solute to a volatile solvent, the vapor pressure of the volatile solvent decreases, and now the vapor pressure of this volatile solvent matches to the vapor pressure of the solid phase at a lower temperature, hence causing reduction in its freezing point. Greater the number of solute particles, greater will be the depression in freezing point, and hence lower will be the freezing point. So we can say that the freezing point of a solvent is inversely proportional to the number of solute particles. Because greater the number of solute particles, greater will be the depression in the freezing point, and hence lower will be the freezing point. Now we are given 4 substances here, 4 non-volatile solutes here. All of them have the same concentration, 0.06 molar. So we just have to check that which solute gives the maximum number of particles per unit. So the first solute is aluminum sulfate that produces 2 aluminum ions and 3 sulfate ions upon dissociation. So the total number of particles furnished by this solute is 5, which we can also say the Van 't Hoff factor is 5. C6H12O6 is seems to be a covalent compound, so it could be glucose, for example. Non-electrolytic solute, here the Van 't Hoff factor is 1, the number of particles remains the same. Ki is again an ionic compound. It produces 2 ions upon dissociation, K plus and I minus, leading to twice as many particles. K2SO4, again it's ionic solid. It produces 3 particles per unit of the molecule K2SO4. So there are 2 potassium ion and 1 sulfate ion, so total of 3. So we can see that it is the aluminum sulfate compound that gives the maximum number of particles. Hence it will produce the maximum depression in freezing point, and it is in this case of aqueous aluminum sulfate, that the freezing point will be lowest. So the correct answer to this question is option A. Thank you. Hi everyone. In this question, we have to compare the ionization energies of some elements with the element magnesium. So this question is basically on the periodic properties of elements, specifically ionization enthalpy. As per the question, the first ionization enthalpy of magnesium element is smaller compared to that of elements X and Y, but higher than that of Z. So the ionization energy of magnesium is higher than the ionization energy of element Z, but the ionization enthalpy of magnesium is smaller compared to the ionization enthalpy of the elements X and Y. So there are four options and we have to select that which one of the options makes sense for the elements X, Y, and Z. So if we see from this order that X and Y should have higher ionization enthalpy compared to magnesium. So for example, if we see the first option, chlorine and aluminum, do they have higher ionization enthalpy than magnesium? Chlorine, yes, but aluminum does not have higher ionization enthalpy, first ionization enthalpy than magnesium, because the electron in magnesium is removed from s orbital, 3s orbital, where the electron from aluminum is removed from 3p orbital. As electron is closer to the nucleus, has higher penetration effect, so therefore the first ionization enthalpy of magnesium is higher than the first ionization enthalpy of aluminum. So this does not make sense. Can X and Y be neon and sodium? Yes, neon does have higher ionization enthalpy than magnesium because neon is a noble gas, but not sodium, right? So this cannot also be correct. Argon, aluminum, and sodium, again, this cannot be correct because aluminum cannot have higher ionization enthalpy than magnesium. Now let us look at the fourth option, argon, chlorine, and sodium. So this is supposed to be, let's say, X, this is Y, and this is Z. So does it make sense? Absolutely. Sodium does have lower ionization enthalpy compared to magnesium because the electron in sodium is 3s1, whereas that in magnesium is 3s2. So because of the higher effective nuclear charge, the ionization enthalpy of magnesium is higher than sodium, and magnesium has a lower ionization enthalpy than argon and chlorine both, again because as we move across the period from left to right in the periodic table, the ionization enthalpy increases. So the option that makes sense and hence is the correct answer is option D. Thank you. Hi everyone. In this question, we are given a molecule that contains a phenyl ring, a bromine attached to a phenyl ring, and a carbon-carbon double bond on the side chain. First, we have to react it with HBr in the presence of peroxide. Reaction of an alkene with HBr in the presence of peroxide is an example of free radical addition, and that occurs as per anti-Markovnikov rule. That is, hydrogen atom goes to that doubly bonded carbon atom which is joined to fewer number of hydrogen atoms, and that is because of the formation of more stable radical. So what happens here is that hydrogen goes to this carbon and bromine goes to this carbon atom. So this is the major product after reaction with HBr in presence of peroxide. Now what happens when we react this molecule with cobalt fluoride? This reaction is an example of Schwarz reaction, which is used for preparing fluoroalkanes from chloro or bromo compound. Now remember that in Schwarz reaction, it is the haloalkane that reacts and not the halorine, because the halogen joined to benzene ring, it's poor leaving group because of the partial double bond character. So what happens when we react it with cobalt fluoride? The bromine joined to sp3 hybridized carbon atom simply gets replaced by fluorine. So this should be the major product in this case, and that is the correct answer would be option D. Thank you. Hi everyone. In this question, we have the reactant benzene. There is a list of reagents with which benzene is reacting, and we have to figure out the major product of this reaction sequence. So let us start with benzene. When it reacts with concentrated HNO3 in presence of H2SO4, this is an example of electrophilic substitution, specifically nitration, where a hydrogen atom on benzene ring is replaced by nitro group. So the product of the first reaction is nitrobenzene. When this nitrobenzene reacts with hydrogen in presence of the catalyst palladium supported over charcoal, then NO2 group is reduced to NH2 group. So that reaction is an example of catalytic reduction. When this compound, which is benzenamine or aniline, reacts with sodium nitrite in presence of HCl, this is an example of diazotization where NaNO2 and HCl react in situ within the reaction mixture. They produce nitrous acid, which then produces an electrophile NO+, which then attacks on the nitrogen of NH2 aniline, and then it produces an intermediate which we call benzene diazonium chloride in this case. So this would be this compound N2 plus Cl minus. Now nitrogen is an excellent group and we can react it with Q plus cyanide CuCN, where this diazo group will get replaced by this cyanide. So we will have benzonitrile as the next product. Benzonitrile, when it reacts with methyl magnesium bromide, so that is an example of nucleophilic addition. So this is our benzonitrile, and CH3 MgBr is our Grignard region, which provides a nucleophile. The carbon of cyanide has delta positive charge because it is joined to more electronegative nitrogen. It attacks here, the pi bond breaks, and the next product that we get here is this carbon double bond nitrogen minus and then CH3. And when we hydrolyze this intermediate in acidic medium, this doubly bonded nitrogen gets replaced by a sequence of steps by an oxo group. So what we have here is this carbon double bond oxygen and then CH3. So the final product in this reaction sequence is acetophenone, which is here option B, right? So out of the four options, A, B, C, and D, the correct answer is this option B. Thank you. Hi everyone. In this question, we are given four reactions and we have to tell that in which of the four options the product is correctly given. So these are miscellaneous reactions from different chapters of organic chemistry. For example, in the first option, we can see that the reactant is a primary alcohol, right? CH2OH. It reacts with a mixture of chromic anhydride, CrO3 plus H2SO4, which is a strong oxidizing agent that we call John's reagent. So this reaction is John's oxidation. In this reaction, what happened that the primary alcohol is oxidized to carboxylic group. So the product here should have been this carboxylic group and not the aldehyde. So this is not the correct answer. In second case, the molecule contains a COCH3 group and a methyl group, and we are oxidizing it with KMnO4 in alkaline medium, right, which is a strong oxidizing agent. So when alkyl benzene, a benzene molecule containing side chain is oxidized using a strong oxidizing agent, the side chain, irrespective of its length, is oxidized to carboxylic group. Of course, if it is an alkyl group, there should be at least one benzylic hydrogen, right? But here you can see that it's already oxidized to ketone, right? So the requirement of benzylic hydrogen is not necessary. The chain breaks here and this carbonyl carbon is oxidized to carboxylic. The reason that this option is incorrect is that this methyl group should also have been oxidized to carboxylic. So the correct product in this case should have been this benzene 1,4-dicarboxylic acid. So option B is also incorrect. In case of option C, we have an alkene. Again, we are oxidizing it with KMnO4 in acidic medium at elevated temperatures. That is a strong oxidizing agent. So what happens when we oxidize an alkene with KMnO4 at high temperature in presence of acidic medium? The carbon double bond carbon breaks, right? Both the vinylic carbon get oxidized to carboxylic group. So in this case, the product is perfect. It is correct. This carbon as well as this carbon both are oxidized to carboxylic. So option C is the correct answer. Anyway, let's see what's wrong with option D. In option D, first we have a benzyl alcohol CH2OH that reacts with HBr. This is a nucleophilic substitution reaction, right, in which the OH is replaced by Br. So this is correct, benzyl bromide. So far so good. But when this benzyl bromide reacts with potassium nitrite, you do not get cyanide here because KNO2 provides a nucleophile NO2 minus that reacts that attacks to oxygen. So the final product that should have been there in this reaction sequence would be CH2ONO, that is alkyl nitrite. So for this reason, option D is incorrect, right? So anyway, we have got a correct answer, option C, that is the correct answer. Thank you. Hi everyone. In this question, we have to find out the minimum percentage error in the measurement of velocity of an electron, for which we are already given that the uncertainty in position, which is delta x, is equal to the de Broglie wavelength of electron, which is lambda. Now we know from the de Broglie concept itself that the wavelength is given by h upon p, where h is Planck's constant and p is the linear momentum of the particle. Also, as per the Heisenberg uncertainty principle, delta x multiplied by delta p, for numerical purpose, we can take it to be equal to h upon 4 pi. Now, the uncertainty in position of electron delta x is lambda, but lambda is equal to h by p. So we can make that substitution, delta x to be replaced by h upon p. Here, Planck's constant cancels out. Also, we do not have to calculate error in momentum, but we have to calculate error in velocity. Assuming the mass of the electron to be constant, delta P can be written as m delta V, and P of course can be written as mv. So this is 1 upon 4 pi. So that gives us delta V by V is equal to 1 upon 4 pi. Now delta V by V is the relative error in velocity. We have to calculate percentage error. So we have to multiply this by 100, which means that delta V by V into 100 is equal to 1 upon 4 pi into 100. The value of pi is not given. We can take it to be approximately 3.14, right? So 4 into 3.14, that approximately is 12.56. So 100 by 12.56 is approximately equal to 8. So the minimum percentage error in the velocity of this electron under this circumstance will be 8%, and hence the correct answer would be option B. Thank you. Hi everyone. This question is based on thermodynamics, specifically the concepts of the first law of thermodynamics. Here we are given that an ideal gas undergoes a cyclic process as shown in the figure below. So we have a pressure versus volume graph in which we have a cyclic process consisting of 3 steps, A to B, B to C, and then back from C to A. We have to calculate that what is the amount of heat absorbed by the system in the final step of this process, which is CA. Because this is a cyclic process and internal energy is a state function, so the total change in internal energy should be 0, which means that delta U in the process AB plus delta U in the process PC plus delta U in the process CA should be equal to 0 because this is a state function. Now, as per the first law of thermodynamics, we know that the change in internal energy is total amount of heat change plus work done. That is a mathematical form of the first law of thermodynamics as we use it in chemistry. So for the process AB, we can see that the change in internal energy is equal to heat absorbed plus work done. In the process AB, we are given that heat absorbed is 2 kilojoule. So in the process AB, heat absorbed is 2 kilojoule plus amount of work done in the process AB is -5. So this is -5. Everything is in the same unit, so we don't have to worry about it. So this is our change in internal energy in the process AB. For process BC, we are directly given that the change in internal energy is -5. So this is -5 for the process BC. Now finally, for the process CA, again we can apply the first law of thermodynamics. For the process C to A, the change in internal energy can be expressed as the sum of heat plus work done. Right, heat we have to calculate, so that is our QCA. and plus what is the work done in going from C to A, that is given here in the question, that is 3. All right, so this is 2 minus 5, so that is minus 3. So this is minus 5, so this is QCA, and this is plus 3. All right, so this is QCA would be minus 8, which goes to the other side, that becomes plus 8, right? And this 3 becomes minus 3, so the change would be plus 5 kilojoule per mole. So the heat absorbed in this cycle, like in this process of C to A, is 5 kilojoule per mole, right? So that should be our, the correct answer should be here, option B. Okay, thank you. Hi everyone. In this question, we have to find out the equilibrium constant for a reaction. Let us look at what the process is. An amount of solid NH4SH is placed in a flask already containing ammonia gas at a certain temperature and 0.5 atm pressure. Ammonium hydrogen sulfide decomposes to yield ammonia and H2S gases in the flask. Okay, so from this equation, we can write the decomposition equation, that NH4SH, which is a solid, it decomposes to produce ammonia gas and H2S gas. Now it is given that already there was some ammonia present in the flask and the pressure of ammonia was 0.5 atm. So in the beginning, we can say that the pressure of ammonia was 0.5 atm at T is equal to 0, and the pressure of H2S, we can take it to be 0. Please remember that NH4SH is a solid, so its pressure will be negligible. We will not consider this. When the decomposition reaction reaches equilibrium, the total pressure rises to 0.84 atm. So when you put ammonium hydrogen sulfide in a flask that already has ammonia, what happens? Reaction goes in the forward direction because one of the products, H2S, is absent. So what happens as time passes, NH4SH decomposes, there is some amount of ammonia and H2S forming. As per the stoichiometry of the reaction, amount of ammonia and H2S formed is equal. So which means that the pressures must also be equal. So if the change in pressure of ammonia is P, the same should be the change in pressure of H2S. So at equilibrium, the total pressure of ammonia should be 0.5 plus P and the pressure of H2S should be P. Now it is already given in the question that the total pressure is 0.84 atm. So we can calculate here that the total pressure is the pressure of ammonia, which is 0.5 plus P, plus pressure of H2S, that is P itself. It is given to be 0.84. When we do this calculation, 0.5 plus 2P is equal to 0.84. P is equal to 0.84 minus 0.5 divided by 2. All right, so this comes out to be 0.34 divided by 2, which is 0.17. Okay, so we can see here that the pressure of ammonia is 0.5 plus P, which is 0.5 plus 0.17, that is 0.67 atm this is, and the pressure of H2S is just P, right? So this is 0.17 atm. Now we have to find out the equilibrium constant, which is Kp. It's nothing but the partial pressure of ammonia multiplied by the partial pressure of H2S, which is 0.67 atm multiplied by 0.17. Okay, now 0.67 is nothing but like 2 by 3. So 2 by 3 multiplied by 0.17, which is 0.34 divided by 3. So this is approximately 0.11. So the equilibrium constant Kp for this equilibrium is approximately 0.11. So the correct answer to this question is option D, 0.11. Thank you. Hi everyone. In this question, we are given some molecules and we have to tell that out of these molecules, the total number of compounds that do not show hyperconjugation. Now, hyperconjugation is a type of electron displacement effect that explains the stabilities of carbocations, free radicals, and alkenes as well. Because these compounds, all of these have carbon-carbon double bonds, so we are looking at basically alkenes here. The condition for hyperconjugation to take place in alkenes is that if this is your carbon-carbon double bond, there should be at least one hydrogen joined to an sp3 hybridized carbon next to the vinyl group, which is the carbon-carbon double bond. So if this is your alkene, there should be at least one alpha hydrogen atom joined to the carbon, which is sp3, which you can see is only possible in the fourth compound because this is carbon-carbon double bond, right? And this is your sp3 hybridized carbon, and here we have 3 alpha hydrogen atom. So in toluene, hyperconjugation takes place. In other compounds, we do not have an alpha hydrogen, a hydrogen joined to sp3 hybridized carbon next to the carbon-carbon double bond. So these three compounds would not exhibit hyperconjugation, and hence the correct answer here would be 3, right? If you're writing in up to 2 decimal places, that will be 3.00. So that would be the correct answer. Thank you. Hi everyone. In this question, we have to prepare a buffer solution of pH 5.74 using sodium acetate, which is a salt of weak acid, acetic acid, and the weak acid itself is of course acetic acid. Now we are given in this question that the concentration of the acid in the buffer is 1 molar. So what should be the concentration of its conjugate base, which is sodium acetate? The data given here is pK of acetic acid is 4.74, and we have to round off the answer to the nearest integer. Because this is a question based on buffer equation, so we shall recall the buffer equation, Henderson-Hasselbalch equation, which is pKa, right, plus log concentration of the salt. Now please remember that this is actually the concentration of conjugate base, right? So in case there is more than one particle of the conjugate base in one formula unit. So concentration of salt divided by concentration of acid. So pKa plus log concentration of salt by acid, this is the ratio of concentrations, is what equals to the pH of the buffer solution. Now we are given that the pH of the buffer solution is 5.74, right? So let us substitute this. pK of acetic acid is given to be 4.74 plus log concentration of salt, which is sodium acetate here, is what we have to find out, divided by the concentration of acid is given to be 1, right? So the concentration of acetic acid in the buffer is 1. So we know that 4.74 taken to that side is 1, right? So we have this log of concentration of salt is 5.74 minus 4.74, which is basically 1. And if log of salt is 1, then the concentration of salt must be 10. So in the unit of molarity, the concentration of sodium acetate should be 10 molar. So the answer would be 10.00 up to 2 decimal place. Thank you. Hi everyone. In this question, we have to find out the volume of a silver nitrate solution that is required for complete precipitation of chloride ions present in 20 ml of 0.01 molar solution of this complex. So this problem is based on the properties of coordination compounds, specifically primary valences and secondary valences. We know that these ions, which are counter ions, they are ionizable, whereas this chloride ion, which is present in the coordination entity, is bonded to the central atom chromium through a coordinate covalent bond, and hence we will assume that it will not ionize. So when this complex CrH2O5 Cl2 is dissolved in water, it dissociates as these two types of ions. All right, so we have 2 chloride ions per formula unit of the complex. So we know that when these 2 chloride ions will react with silver nitrate, right, we will get a white precipitate of AgCl. Because silver nitrate gives 1 silver, whereas this complex gives 2 chloride, so we will need 2 units of silver nitrate to react with 1 unit of the complex. In other words, mathematically, the number of moles of silver nitrate required for complete reaction would be twice the number of moles of the complex, because each complex gives 2 chloride. So if the number of complex is 1, the number of moles of silver nitrate would be 2. Now we know that number of moles is molarity into volume. So for silver nitrate, the molarity is 0.1. The volume we have to calculate. For the complex, number of moles of the complex would be again molarity into volume. Molarity is 0.01, whereas volume is given to be 20 ml. So we can see that this can be written as 0.1 multiplied by V is 4 multiplied by 0.1. So this 0.1 cancels out and the volume comes out to be 4 ml. So the amount of silver nitrate of 0.1 molarity that we need for complete reaction is 4 ml. That is the correct answer. Thank you. Hi everyone. In this question, there is a compound A, which is the simplest optically active alkene. First, it undergoes catalytic hydrogenation in presence of nickel as catalyst, and then the reduction product subsequently reacts with halogen. The question is the total number of monohalogenated organic products in the following reaction. We also have to consider the stereoisomers, in this case, optical isomers. So let us now start by thinking what could be the smallest optically active alkene, right? So let us think about this CH2 double bond CH, right? This is the smallest alkene, but we have to make it optically active, which means that I can take a carbon here, put one hydrogen here, one methyl here, and we have to put another group so that this carbon becomes chiral, and that would be this group. So we can say that this is the smallest optically active acyclic alkene. Okay, now when this molecule undergoes catalytic hydrogenation, of course, this carbon-carbon double bond here becomes hydrogenated, right? It undergoes reduction. So now the molecule that we have is CH3, CH2, CH, CH3, and CH2 and CH3. So we basically have 3-methyl pentane here as the alkane that undergoes monohalogenation. Now, please remember here that in this molecule, this is a symmetrical molecule. So we have how many types of carbon atoms here? Let's see, 1 and 1. I'm marking them 1 and 1 as in these two carbons are equivalent. Similarly, 2 and 2. These two carbons are also equivalent. Let us mark this as 3 and let us mark this as 4. So this molecule has basically 4 types of carbon atoms. Now, if one of the hydrogens is substituted by a halogen atom on C1, the product that we obtain is, let's say, CH2X, CH2, CH, CH3, and CH2 and CH3. So you can notice that there is one chiral carbon in this molecule. This is the chiral carbon. How is this a chiral carbon? Because it has one hydrogen, one methyl, one CH2, CH3, and this is the fourth group, which is different from the rest of the three. So because it has one chiral carbon, there will be two isomers here, a pair of enantiomers, DL isomers. So we have two isomers here. Now let us look at the carbon 2. If a hydrogen on C2 is substituted by a halogen atom, the molecule that we obtain is CH3, CHX, CH, CH3, and C2CH3, right? CH2, CH3. So now if you look closely, this molecule has not just one, but two chiral carbon atoms. This is a chiral carbon because this carbon is joined to a halogen, hydrogen, methyl, and this sec-butyl group. And this is also a chiral carbon. It is joined to methyl, ethyl, hydrogen, and this CH3, CHX. So because there is no symmetry in this molecule and it has two chiral carbon atoms, so the total number of isomers that would be possible is 4 here, right? So total 4 optical isomers would be possible. Now looking at the C3 and C4, if we substitute this hydrogen, the product that results is this. Is there any chirality in this monohalogenated product? Of course not. because this carbon is joined to two ethyl groups which are similar. So there is no chirality. So this is just one molecule. If we replace the hydrogen on C4 by a halogen, so let's say like CH2X. So now this is a product that we get. Again, is there any chirality? No, there is no chirality. This carbon is not chiral because it is joined to two similar groups ethyl, and there's no chiral carbon. So this is one isomer. So the total number of isomers that we obtain, right? All molecules, all isomers, that would be two of these, four of these, one of these, and one of these, right? So the total number of isomers would be 8. So 8 would be our correct answer. Thank you. Hi everyone. In this question, we are given an organic molecule and we have to find out how many of the hydrogen atoms present in this molecule can be generally termed as acidic, right? So the question basically is the number of acidic hydrogen atoms present in the given compound. Let us analyze one by one. The hydrogen atom joined to the formyl group, like present in the formyl group, is generally not considered as acidic because the negative charge on carbon would not be stable, by any significant effect here. So this hydrogen we do not consider it acidic. The hydrogen present in the thiol group is acidic, right? Because SH group is acidic itself, so it can react with a strong base. So this qualifies as an acidic hydrogen. The hydrogen present in the carboxylic group is of course acidic because carboxylic acids are acids. So this also qualifies. Terminal alkynes are also acidic in organic chemistry because they can react with a strong base like sodium or sodamide, and we can get the corresponding conjugate base like this. So terminal hydrogens in terminal alkynes, they're also acidic. So this also qualifies as acidic hydrogen. This is of course not acidic. This is vinylic hydrogen. Now there is one hydrogen in this molecule that is latent, hidden, right? That is acidic. It is this hydrogen. If we remove this hydrogen and look at the ring system, so we can just make that part of the molecule which is required here. So this is a 5-membered ring. There are 2 double bonds already present, and this 5th carbon, which is having one hydrogen, if this hydrogen leaves as H plus, we are going to get a negative charge here. So you can clearly see that we have a total of 6 pi electrons here, which make this ring aromatic, which means the conjugate base of this 5-membered ring is stable due to aromaticity, and hence this hydrogen, which is latent hidden, is also acidic in this molecule. So the total number of acidic hydrogen in this molecule is 4. That would be the correct answer. Thank you.
Hi everyone, I'm Firoz Khan, Master Teacher of Mathematics here at Vedantu. So we are going to discuss mathematics paper of JMMT2 today. So let's start discussion without wasting time. And here is the first question on your screen. So the first question is based on an ellipse. Ellipse is x square plus 9y square is equal to 9. It intersects the positive x and y axis at the points A and B respectively. So this ellipse, in a standard form, it can be written as x square over 9 plus y square over 1 is equal to 1, right? So basically, the vertices of this ellipse are 3, 0 and minus 3, 0, and ends of minor axis are 0, 1 and 0, minus 1. So A point is basically 3, 0. This A point is 3, 0. B point is 0, 1. Now we are drawing. Let the major axis E be the diameter of the circle C. So taking the major axis of ellipse as diameter, we are drawing the circle C. Basically, circle C is the auxiliary circle of the ellipse. Auxiliary circle means the circle drawn on the major axis as diameter. And this, let the line passing through A and B meets this circle at the point P. If the area of the triangle AP and the origin O, means area of triangle OAP, OAP. Okay. Area of triangle OAP is M by N. So what will be the value of m minus n? So let's draw the figure. So let me show you the figure straight away. So if I draw the figure here, let me show you the figure first. Then I will explain the solution, okay, how to do it. So here is the figure for you. Just look at the figure, solution I will explain. So this is your ellipse x square over 9 plus y square over 1 is equal to 1. This ellipse is basically what? X square over 9 plus y square over 1 is equal to 1. Right? And this point is A, 3 comma 0. This point is B, 0 comma 1. So you have drawn a line passing through A and B. So what is the equation of the line? Equation of line AB is obviously the x-intercept of this line is 3, y-intercept is 1. So this line is x over 3 plus y over 1 is equal to 1. Or we can write it as x plus 3y is equal to 3. Now we have drawn a circle taking this major axis as diameter. So let's say major axis is A dash. So taking A dash as diameter, you have drawn a circle, this circle. Obviously, the center of this circle is origin, radius is 3. So what is the equation of this circle? The equation of this circle is x square plus y square is equal to 3 square, means 9. Now this line AB meets the circle at the point P. So A point is already known. Let's find the point P. How will you find the point P? So just solve the equation of the line with the equation of the circle. Means solve this equation 1 with this equation 2. And I need area of this triangle, area of triangle OAP. Right? So basically the area of this triangle is what? Half base into altitude, base is OA, and altitude is nothing but the y coordinate of P. So I just need y coordinate of P only. So let's solve for y. If I solve these two equations, so from the first equation x is 3 minus 3y, or I can say ki x is 3 times 1 minus y, and substitute this x in the second equation. So you are getting this. Now I am getting 9 times 1 minus 2y plus y square is equal to 9. Let's solve this. So 9 will be cancelled. So I am getting minus 18y plus 10y square is equal to 9. So this gives you y is equal to 0 or y is equal to 18 by 10. 18 by 10 means 9 by 5. So basically the y coordinate of the point P is 9 by 5. Y coordinate of the point P is 9 by 5. Whatever is the x coordinate, it doesn't matter. Let's say x coordinate is alpha here. No need to find alpha. Now what is area of triangle OAP? This is what they are asking. So area of triangle OAP is half. Base, which is OA, means 3. Altitude, which is y coordinate of P, 9 by 5. So this area is 27 by 10. And this area was given as m by n. Now they are asking m minus n. So obviously m minus n is 17. So 17 should be the correct answer here. And which option is 17? So if you look at the option here, just look at the option, which option gives you 17. So here option C is correct. C option gives you 17. Clear? Chalo, let's move to the next question now. So here is the next question for you. So two sets are given to you here, A and B. A is 2, 3, 4, B is 8, 9, 12. And we have to find the number of elements in this relation. Relation is what? Relation is on the set A cross B. And obviously A cross B will contain elements like this, A comma B type element. So you are relating two pairs, A1 comma B1 and A2 comma B2. A1 should divide B2 and A2 should divide B1. A1 should divide B2 and A2 should divide B1. So then number of elements in this relation means in short they are asking how many pairs like this you can form A1, B1, A2, B2 so that A1 divides B2, A2 divides B1. That's it. So basically we have to form pairs like this A1, B1, A2, A1 divides B2. A1 divides B2. So see, if I take A1 as 2, in fact, let me write like this, ki A1 divides B2, A2 divides B1, right? So let me write like this, ki A1, B2, then A2, B1. A1 divides B2, A2 divides B1. So if I take A1 as 2, A1 as 2, then B2 can be what? See, 2 must divide B2. So B2 can be 8 and 12. Means for A1 is equal to 2, there are two possibilities for B2. If A1 is 2, then B2 can be 8 and 12. If A1 is 3, then B2 can be 9 and 12. If A2 is 4, then B2 can be 8 and 12. Means for every possible value of A1, there are two possible values of B2. There are two possible values of B2. So basically what we can do here, we can choose A1. We can choose A1 in three ways. A1 can be 2, A1 can be 3, A1 can be 4. And for every possible value of A1, there will be two values of B2. So B2 can be chosen in only two ways. B2 can be chosen in only two ways. See, for example, if A1 is 2, B2 can be 8 and 12. Two ways only. If A1 is 3, B2 can be 9 and 12. So for every possible value of A1, there are two possible values of B2. So B2 can be selected in two ways. Now let's choose A2. So again, A2 can be selected in three ways. And for every possible value of A2, there are two possibilities value of B1. So again, two ways. So total number of ways, and obviously you have to choose all these things, means you have to do all these works. So total number of ways will be 3 into 2 into 3 into 2, which is 36. The total number of pairs should be 36 here. Means option B should be the correct option. Right? Chalo, let's move to the next question. Read this question very carefully. Based on statistics, A and B have 5 elements each. Number of elements in A and number of elements in B both are 5. And mean of these elements in the set A and B are 5 and 8. Means mean of the elements of A is 5. Mean of the elements of B is 8. Right? And variance are 12 and 20. Means mean of the elements of A, variance of elements of A is 12 and variance of elements of B is 20. Now we are forming a new set C. C contains 10 elements. Out of which these 10 elements, 5 elements will be taken by subtracting 3 from each of elements of A. And 5 elements will be taken by adding 2 to each element of B. Then the sum of the mean and the variance of the elements of C. Okay. So what I can do here, I can divide the set C, means I can divide the set of elements of C into two parts. Here N1 is 5 elements which I am taking from the set A after subtracting what? After subtracting 3. And 5 elements I am taking from the set B after adding 2. So N2 is also 2. Means 5 elements from A, 5 elements from B. Now what will be the mean of these 5 elements which I am taking from the set A? So see, original mean was 5. Original mean was 5 here. But since you are subtracting 3 from each element of A, so now the mean of these 5 elements will be 5 minus 3, which is 2. Now the mean of these 5 elements will be 5 minus 3, which is 2. And what is the mean of these 5 elements? So originally the mean of 5 elements of B is 8. But you have added 2 to each element. And since you have added 2 to each element, the new mean will become 8 plus 2, which is 10. Now what will is the variance of these 5 elements? The variance of 5 elements of A is 12. And this will remain same. There will be no change in the variance, because if you increase or decrease each observation by a constant quantity, then the variance remains same. There will not be any change in the variance if you increase each observation by a constant quantity, or if you decrease each observation by a constant quantity. The variance will remain same here, 12 and 20. And now I'm combining these 5 plus 5 elements, means 10 elements. Sorry, we have 5 here. Why I have written 2? It is 5 here. So now I'm combining these 5 plus 5, 10 elements. So what will be the combined variance of these 10 elements? So to get the combined variance of these 10 elements, let's find the combined mean of these 10 elements first. What I'm finding? Combined mean. So combined mean will be N1 x1 bar plus N2 x2 bar over N1 plus N2. This is the combined. N1 x1 bar 5 into 2, 10. N2 x2 bar 5 into 10, 50. N1 plus N2, 10. So it is 6, the combined mean. Now what is the combined variance? So let's say combined variance is sigma square. And the formula for combined variance is N1 times sigma 1 square plus D1 square plus N2 times sigma 2 square plus D2 square over N1 plus N2. This is the formula to find the combined variance. Now N1 is known, N2 is known, sigma 1 square is known, sigma 2 is square. Now what are these D1 and D2? So actually D1 and D2 are the difference. See, D1 is the difference of x1 bar and x bar. So D1 is nothing but 2 minus 6, which is minus 4. Or you can say 6 minus 2, absolute difference. So D1 is basically 2 minus 6, which is minus 4. D2 is the difference of x2 bar and x bar. So 10 minus 6, which is plus 4. Now let's put the value here. So N1 is 5, sigma 1 square is 12, D1 square is 16, N2 is again 5, sigma 2 square is 20, D2 square is 16, and in the denominator you have N1 plus N2 means 10. 5 can be taken common, so you have 28 here, then you have 36 here, 5 taken common, so you have 2 here. So this is 14 plus 18, means 32 should be your correct answer. So the answer to this question is 32, which is option A. Is it 32 or 38? Oh, sorry, 18. I'm getting 32. Any calculation error I'm doing? Let me check. So N1 is 5, N2 is 5. Original mean was what? Original mean was 5. So subtracted 3, 2 here. And original mean for B was 8. Added 2 here, so 10. Combined mean will be N1 x1 bar 5 into 2, 10. 5 into 10, 50. 10, so 66, it is correct. So D1 is 2 minus 6 minus 42 is 20 minus 6, which is plus 4. So this is combined mean 5, sigma 1 is square 12, D1 is square 16, N2 5, sigma 2 is square. Sigma 2 square is what? Sigma 2 square is 20, D2 square is again 16. So I'm getting 16 plus 12, 28, 20 plus 16, 36, 28 by 2, 14, 36 by 2, 18. I am getting 32. Or they are getting 38. Oh, sorry. And in fact, I have not read the question completely. The question is asking the sum of mean and variance. Sorry, my bad. The question is asking sum of mean and variance of the elements of C. The sum of mean and variance, sum of mean and variance. Actually, it happens to me many times, and I have a very bad habit of not reading the question completely. So what they are asking sum of mean and variance of the elements of C. So see, elements of C, mean is combined mean is the mean 6 here and variance is 32 here. So yes, 38 is correct answer. Means option D. Sorry, I messed it up. It was not that difficult if I have read the question carefully. Let's move to the next question. This integration is 0 to infinity 6 over e raised to 3x plus 6 times e raised to 2x plus 11 e raised to x plus 60x. We have to integrate it. So basically what you can do here, you first do the partial fraction of these things. Supposing e raised to x as t. Supposing e raised to x as t. So I'm not substituting e raised to x as t in the integration. Be careful. I'm just doing partial fraction by taking e raised to x as t. So this will be 6 over t cube plus 6 et square, 6t square, e raised to x is taken as t, plus 11t plus 6. T is taken as e raised to x. Again, I'm repeating, I'm not substituting e raised to x as t in the integration. Just for partial fraction, I'm taking e raised to x as t. And now I can factorize it as 6 times. It can be factorized as t plus 1, t plus 2, t plus 3. And then I can do its partial fraction a over t plus 1, b over t plus 2, c over t plus 3. And just by partial fraction method, I can find a, b, c. So let me show you the solution straight away, because no concept here is here. Just do the partial fraction. So if I do the partial fraction of this 6 over t plus 1, t plus 2, t plus 3, like this. If I do its partial fraction as a over t plus 1, t over t plus 2, and c over t plus 3. Just do the partial fraction. So ultimately you will see that a is 3, a, in fact, yes, a will be 3, b will be minus 6, and c is again 3. Just do the partial fraction. So a is 3, b is minus 6, c is 3. So now I can integrate. My integration is what? 0 to infinity. A is 3, so it is 3 over t plus 1, and t is e raised to x plus 1 dx. This is the first integration. B is minus 6 to 0 to infinity 6 over e raised to x plus 2. And c is again 3. So 0 to infinity 3 over e raised to x plus 3. And now I have to integrate these three things. Now if I write e raised to x as 1 over e raised to minus x, so this will become 3 times 0 to infinity e raised to minus x over 1 plus e raised to minus x dx. This is 6 times 0 to infinity e raised to minus x over 1 plus 2 times e raised to minus x. And finally 3 times 0 to infinity e raised to minus x over 1 plus 3 e raised to minus. And now you can see that the derivative of e raised to minus x is minus e raised to minus x. So if I write minus here, so this will become minus. If I write minus here, so this will become plus. If I write minus here, so this last one will become minus. And not just substitute e raised to minus x as, let's say, z. In fact, you can do like this also. The derivative of complete denominator. Let me write the complete denominator. Let me erase these things. Originally it was plus, minus, plus, plus, minus, plus. Now just try to integrate this. So see, the derivative of denominator is here. If I take the denominator as z, so e raised to minus x dx will become dz. So this integration is basically minus 3 times log 1 plus e raised to minus x. Lower limit 0, upper limit infinity. Here if you take the denominator as z in the second one, so e raised to minus x dx will become minus half dz. So this will become actually 6 into half plus 6 into half. So 3 times log 1 plus 2 e raised to minus x. 0 to infinity. And here if you put denominator as z, so e raised to minus x dx will become minus 1 by 3 dz. So this is minus log 1 plus 3 e raised to minus x 0 to infinity. And after that it is just simplification thing. Just substitute upper limit and lower limit. And one more thing you should keep in your mind, e raised to minus infinity will be approaching to 0. So whenever you are writing e raised to minus infinity, write it as 0. And after that, just some simplification thing, simplify, you will get the integration like ln 32 by 27. So ln 32 by 27 means A option should be correct option. Let's move to the next question now. Question number 5. What they are saying, that this quantity satisfies this quadratic. So then what will be the value of this one? So let's see this quantity first. This quantity is what? E raised to cos square x plus cos raised to 4x plus cos raised to 6x. This is a GP with first term cos square x, common ratio also cos square x, are in infinite GP. So a over 1 minus r, infinite GP formula. A over 1 minus r, infinite GP formula. And then we have log 2 with the base e. So this becomes e raised to cos square x over sin square x, means e raised to cot square x. So it can be written as e raised to log 2 raised to cot square x with the base e, and which is nothing but 2 raised to cot square x only. Actually, e raised to ln x is same as x. And this is, they are saying that this quantity is a root of this equation. This equation can be factorized as t minus 1, t minus 8. The roots are 1 and 8. So that simply means that this quantity should be 1 or should be 8. 1 can be written as 2 raised to 0. 8 can be written as 2 raised to 3. So that simply means that cot square x is either 0 or 3. But x lies between 0 and pi by 2, open at pi by 2. So cot square x cannot be 0. 0 is not possible. So I will take cot x as root 3 only. And you will take only positive sign because angle lies in the first quadrant. Cot x is root 3 means x is 30 degree. And just put 30 degree here in place of sine and cos, you will get your answer. Just put x is equal to 30 degree here, you will get your answer. The correct answer is A. Let's see this question, question number 6. We have e raised to sine square x cos x sin 2x minus sin x dx. This question is just based on a standard formula. Standard formula is what? If you have e raised to gx g dash x fx plus f dash x dx. So integration becomes e raised to gx fx plus. And you can see that for your question, gx is sine square x, g dash x will become 2 sin x cos x, which is sin 2x, fx is cos x. So f dash x will become minus sin x. So your integration is what? E raised to gx is what? Sin square x. Fx is what? Cos x plus. And this integration is called Ix here. I0 is 1. So if I find I0 here, so I0 will be e raised to 0, 1 cos 0, 1, 1 plus c. And I0 is 1. So that means c is 0. Now they are asking I pi by 3. So if you put pi by 3 here, so sin pi by 3 root 3 by 2, but is square to 3 by 4. Cos pi by 3 is half. So half e raised to 3 by 4 means first option should be the correct option. Let's take the next question. So this question is based on matrices. A is an invertible matrix 3 by 3. You have to pick the option which is not correct. Pick the option which is not correct here. So basically this is just based on properties of adjoint. So what are the properties of adjoint? One property you know, कि A into adjoint A is determinant of A into I. Another property you know, कि determinant of adjoint A is determinant of A raised to n minus 1. N is order, which is 3 here, to square. One property you know that कि A inverse is adjoint of A over determinant of A. So I can write adjoint of A as determinant of A into A inverse. So this option is correct. Adjoint of A, determinant of A into A inverse. So this is correct. Now if I replace A with adjoint A here, if I replace A with adjoint of A here, so adjoint of adjoint A is determinant of adjoint A into adjoint of A inverse. And determinant of adjoint A is determinant of A square and adjoint of A inverse. It is bracket actually. So this option is also correct. This option is also correct. And one more thing, adjoint of adjoint is determinant of A square. This option is not correct for sure. This option is not correct for sure. And this will be true. This is again a property. Adjoint of adjoint is determinant of A raised to n minus 2 into A. So n is 3 here. So this one is also correct. Means first option is not correct here. So your option should be, your answer should be A option. See this question. They are saying that the maximum and minimum value of this function in this interval are small k and capital K. Small k is minimum, capital K is maximum. So you have to find this. So actually this is straightforward question. Just check the derivative. So you will find that the derivative is actually negative for all x belonging to 0. You can check it carefully. It's not very difficult. Derivative is negative for all x belonging to 0 to 1. In fact, even in closed interval 0 to 1, derivative comes out to be negative. And since derivative is negative for all x belonging to 0 to 1, so I can say that this function is a decreasing function. This function is basically a decreasing function. So fx is a decreasing function. And since it is a decreasing function, means graph is going down. So obviously at 0 you will get the maximum value, at 1 you will get the minimum value. So maximum value means capital K is f0. And f0 is what? f0 is basically 1. And a small k is f1. So which is 2 raised to 0.6. 1 plus 1, 2 raised to 0.6. Let me check. F1 will be what? Yes. 2 raised to 0.6. And denominator is 2. So it is basically 2 raised to minus 0.4. This is small k. So again, option A should be the correct option here. Least value is 2 raised to minus 0.4. Greatest value is 1. Derivative you can check easily. Just differentiate using quotient rule. You will get your answer. It's not very difficult. Let's see the next question. The angle between these two lines is given as cos inverse 2 by 3. Then what will be P? So first I have to convert both the lines in a standard form. This is already in a standard form. Its direction ratios are 2 to 1. And if I convert this second equation in a standard form, so I can write it as x minus 5 by 2. Let's divide by 7 here. So y minus 2 over p by 2. And this one is z minus 3 by 4. So now it is in standard form. So if I find the angle between these two lines, the angle will be what? Cos theta will be 2 into 2, which is 4, plus 2 into p by 2, which is p, 1 into 4, which is 4, and divided by under root 4 plus 1 under root 9, and under root 4 plus p square by 4 plus 16. And theta is given here, cos inverse 2 by 3. This is given. So that means cos theta is 2 by 3. So this should be equal to 2 by 3. Of course, you will take absolute value here. Now just do a squaring both sides and simplify. So you will get the possible value. It's not very difficult. Just do the squaring thing and you will get your value. So after squaring, you will get p is equal to 7 by 2. So p is equal to 7 by 2 is the value when you square it. So 7 by 2 means first option is the correct option. Next question. Next question is A, B are real numbers. Mirror image of the point this with respect to line this is this. So basically what they are saying, if we have a line and these 2 points are mirror image with respect to each other. So basically, you know that the midpoint of object and image will always lies on the mirror. So just take the midpoint a plus 20 by 2, 6 plus b minus a by 2, 9 minus a minus, and that should satisfy this line. So what you will do simply is just take the middle point of this P point and its image. The middle point is what? A plus 20 by 2, 6 plus b by 2, and 9 minus a minus 9 by 2 means minus a by 2. 9 minus a. And obviously, let's say this is your mirror line. This is your mirror line. This is the point P. And suppose its image is point Q. Q point is this point. This is image. So midpoint, let's say midpoint is in. Obviously, it will satisfy the line, satisfy the mirror. So this point must satisfy the mirror. So just put x is equal to, in the line, put x is equal to a plus 20 by 2, y is equal to 6 plus b by 2, z is equal to minus a by 2 and solve. You will get the values of a and b. So it is not very difficult. Just substitute this middle point in the given line. A will be your correct answer. If you substitute here, and solve, so you are getting a is equal to minus 56, b is equal to minus 3. They are asking absolute value of the sum. So absolute value of the sum is 88. Let's see the next question. They are asking in this function is increasing in the set A. So what will be the set A? Means for what values of x the function is increasing. In short, set A contains all the values of x where the function is increasing. So you have to find the set A. Means in short, you have to find the interval where your function will be increasing. And you know that your function will be increasing when the derivative is positive or greater than or equal to 0. So if I check the derivative here, the minus 55 here, obviously in this interval function is not increasing, it is decreasing here, derivative is negative. Now let's differentiate this one. So it is 6x square minus 6x minus 120 when x lies between minus 5 and minus 4. And then 6x square minus 6x minus 36 when x is greater than 4. Right. Now, the points where the function is changing its rule, you can take it closed interval or open interval, it doesn't matter. For that, we have to check the differentiability. But if I look at the options, every option, all the intervals are open interval. So that's why I'm not checking it. No need to waste my time. So let's differentiate, factorize. See, this option is already rejected here because here the derivative is negative. So just check these two now. So I'm checking last two. If I take 6 common here, so it is x square minus x minus 20. X square minus x minus 20, I think it can be factorized. X minus 5, x plus 4. When x lies between minus 5 and 4, not minus 4. I've written minus 4 here. Actually, it is plus 4 here. And similarly, if I take 6 common here in the second one, so x square minus x minus 6. So that can be factorized as x square minus x minus 6. So that can be factorized as x minus 6x plus 5. X plus 1. Is it right? X square minus 6x minus 6. X square minus x minus 6. Sorry. No, it's not right. Minus 3 plus 2, I think it should be. Yeah. X minus 3x plus 2. 6 taken common, and we are left with x square minus x minus 6. So yes, x square minus x minus 6. Now check the sign. So see, this quantity will be negative between, this quantity will be negative between minus 4 and 5. Will be negative between minus 4 and 5. I'm just checking the sign of this one. Let's check the sign of this one first. This one. So if I check the sign of this one, the sign changes at minus 4 and 5. Positive here, negative here, positive here. But we are taking the interval minus 5 to 4. We are taking the interval minus 5 to 4. So let's say minus 5 here, 4 here. So obviously in this interval from minus 5 to 4, derivative is positive between minus 5 and minus 4. So that means here the derivative is positive in the interval minus 5 to minus 4. In this interval from here to here, minus 5 to minus 4, derivative is positive. So this rule is increasing in the interval minus 5 to minus 4. Now let's check the next one. Next one means, okay, let's check this one now. This one. So see, for x greater than 4, if I take x greater than 4, so this is always positive. For all x greater than 4, it is positive. So that means ki function is increasing in -5 to -4 union 4 to infinity. So -5 to -4 union 4 to infinity. Option C should be the correct option. Next question. If this point lies on the curve traced by the middle point of the line segment between the coordinate axes, so what will be alpha here? And this is given that this angle theta lies between 0 and pi by 2. So let's say this line meets x-axis at A, y-axis at. So what is A here? A lies on the x-axis, so put y0. So A will be 7 by cos theta, comma 0. And what is B here? B lies on the y-axis, so put x0, 7 by sine. So what is the middle point of AB? Let's say middle point of AB is M. So that is 7 by 2 cos theta, 7 by 2 sine theta. And they are saying that this point lies on the curve traced by the middle point. So that means if for set some value of theta, M should become this. Means M should be equal to alpha 7 root 3 by 3 for some angle theta, because this point lies on the curve traced by the middle point. So hence this point must be represented by this one for some theta. So now I can say that ki alpha is what? Alpha is 7 by 2 cos theta. And 7 by 2 sine theta is 7 by 2 sine theta is 7 root 3 by 3. So basically 7 cancel. If I find sine theta from here, so sine theta will be root 3 by 2. Means theta is 60 degree. So for 60 degree, this M point will become alpha comma 7 root 3 by 2. So alpha is what? 7 over 2 cos 60 degree. Cos 60 degree is half. So it is 7. So alpha will be 7 here. See this question. A is 1 comma 51, 0 comma 1, and B is this matrix. So we have to find sigma n varying from 1 to 50, B raised to n. In fact, we have to find the sum of elements of this summation. Sum of elements of this matrix, sigma n varying from 1 to infinity, B raised to n. And B raised to n is what? Whole raised to n here. So in fact, let me write B matrix as, C A D, and I have taken C matrix as 1 2 minus 1 minus 1, and D matrix as minus 1 minus 2 1 1. And if you multiply C and D, just multiply and check, so you will find that this product of C and D is I. Means they are inverse of each other. So I can write that D is nothing but C inverse. So now I can say that matrix B is nothing but C A C inverse. And if I raise to power n here, so this will be simply C A raised to n C inverse. This is just a property. If you have a matrix of this form, C A C inverse type or C inverse AC type, and if you raise it to power n, then power goes to the middle one only. Keep it as a property in your mind. This is a very useful property. So the power goes in the to the middle matrix only. So C A raised to n A inverse. So basically B raised to n is what? C A raised to n D. C inverse is D. So now I need A raised to n. Now I need A raised to n. So to get A raised to n, what I will do, just to find the matrix A raised to n, just find pattern. Let's find A square, A cube, A raised to 4 and see what pattern, in which pattern the elements are moving, elements of A raised to n. So if you find A square, A cube, something like this, let me show you. So your matrix A is what? Your matrix A is, let me show you here. A is 1, 1 by 51, 0, 1. Next, find A square. A square means multiply A with A itself. So you will see that it becomes 1, 2 by 51, 0, 1. So only one element changes. 1 by 51 becomes 2 by 51. If you check A cube, so you will get 1, 3 by 51, 0. So just check A square, A cube. A is already given. Just check A square and A cube. You got the pattern. Only one element is changing here. So by observing this pattern, I can say that my AN will be what? A1, n by 51, 0. This is AN. Now I have to find B raised to n. B raised to n means what? C A raised to n D. C A raised to n D. So C matrix is what? C matrix is 1, 2, minus 1, minus 1. A raised to n matrix is what? 1, n by 51, 0, 1. And D matrix is what? Minus 1, minus 2, 0. Now just multiply these three matrices. No concept, simple multiplication. So if you multiply these three matrices, no concept, no property, just simple multiplication. So if you multiply these three matrices, you will get what? You will get n by 51 plus 1, n by 51 minus n by 51, 1 minus n by 50. Now what we have to find? We have to find sigma b raised to n, n varying from what? N varying from, let me check, n was varying from 1 to 50. So n varying from 1 to 50. And we need not the matrix B raised to n, we just need the sum of elements. So we need sum of elements of B raised to n, n varying from 1 to 50. So I can write it as sigma n varying, we need sum of elements only. So n varying from 1 to 50. Now what is the sum of element? Just add these four elements here. So you will see that if I add these four elements, so sum will be 2 only. Just check. Sum of these four elements is 2. So it becomes sigma 2 only. And 50 elements, so 2 into 50 means 100 should be your correct answer. So correct answer is straight away 100, which is option. Next question, question number 14. x1, x2, xn are in AP, and then 1 by h1, 1 by h2, 1 by hn also in AP. So here, first look at this AP, x1, x2, x3, X set. Why I'm going up to X set? Because I know X set. X set is 20. This is an AP. And I know two elements here. Let's say the first term of this AP is A, common difference is 2, D. So X3 will be what? X3 will be A plus 2D. First term is A, common difference is D. This is given as 8. And X set will be what? A plus 7D. This is given as 20. Now if I subtract these two, second minus first, so 7 minus 2, 5D. 20 minus 8, 12. So D is 12 by 5. Just put the value of D here in any one equation. So you are getting A is equal to 8 minus 24 by 5. 8 minus 24 by 5. So which is 16 by 5. I need what? I need X5. So X5 is A plus 4D. A is 16 by 5. 4D. D is 4D is 48 by 5. So it is 64 by 5. This is X5. Now let's check. Second one. 1 by H1. 1 by H2. Up to 1 by H7. This is also AP. Let's say the first term of this AP is capital A, common difference is capital D. So H2 is 8. So means second term of this AP is 1 by 8. Second term will be A plus D. First term capital A, common difference capital D. 1 by 2, 1 by 8. And seventh term of this AP is 1 by 20. Seventh term means A plus 60. 1 by 20. Now if you subtract, so 5D will be 1 by 20 minus 1 by 5. So here you are getting 1 minus 4 by 20 minus 3 by 20. This is 5D. So D will be what? Minus 3 by 100. Now if I put the value of D here in any one equation, so A will be what? A will be 1 by 8 plus 3 by 100. LCM of 8 and 100 is 20. So I'm getting 25 plus 6, 31 by 200. Now I need H10 here. So 1 by H10 is what? 1 by H10 is A plus 90. A is what? A is 30. A is what? A is 31 by 200. 9D. 9D is minus 27 by 100. So it is what? LCM 200. So I'm getting 31 minus 54 here. Why I'm getting negative value? Because I don't have negative value in the option. (31 by 200). This is A. Yes. And 9D. 9D is minus 27 by, oh, sorry. This one is wrong. D is what? Minus 3 by 100. Yes, 5D 1 by 20 minus 1 by 4. Everything is wrong here. I have to calculate once again. Everything is wrong here. So let me calculate once again. So 5D is what? 1 by 20 minus 1 by 8, not 1 by 5. See, 1 by 20 minus 1 by 8. So LCM will be 40. So which is 2 here, 5 here, minus 3 by 40. So D will be minus 3 by 200. Then A will be what? A will be 1 by 8 plus 3 by 200. So now it is 28 by 200. 28 by 200. And I need what? I need H10. So 1 by H10 is A plus 90. A plus 90. A is what? A is 28 by 200. And 90 is minus 27 by 200. 90 is minus 27 by 200. So it is 1 by 200. Now what they are asking? They are asking x5 multiplied with h10. x5 is what? 64 by 5. And h10 is 200. So basically it is 64 into 40. So 2560. This should be your answer. Option A. Let's see this question. Question number 15. One minus x plus x cube whole raised to n is this summation. So summation basically given 1 minus x plus x cube whole raised to n. It is given a0 plus a1 plus a2 plus a3 up to a3n. Now if I put x is equal to 1 and minus 1 here respectively. So for x is equal to 1, I will get sum of all the coefficients a0 plus a1 plus a2 plus a3, all the coefficients. It is 1. And if I put x is equal to minus 1, so then I will get a0 minus a1 plus a2 minus a3 like that. And this is 3 raised to n. X is equal to minus 1 will be not 2 raised to n, not 3 raised to n. Let me check. If I put x is equal to minus 1, for c x is equal to 1, it is 1. X is equal to minus 1, it is 1 plus 1, it is also 1 actually. 1 plus 1 minus 1. So both are 1. Now if I add these two, so I will get 2 times even coefficients, means I will get 2 times a2j, this summation. 2 times a2j, that will be 2. And if I subtract, I will get 2 times a2j plus 1, this summation, which is 0. So now you got the answer. Your answer is basically what? This summation summation, this one, a to j, j varying from 0 to integral part of, in fact, simple sum of even coefficients, that will be 1. So this one is 1 and this one is 0. So 4 into 0 here. The 1 should be your answer. 1 plus 4 into 0. Next question. Largest value of mod z by solving this inequality. So let's remove the log first. So I'm getting mod z plus 11 over mod z minus 1 whole square is greater than or equal to 1 by root 2 raised to 2. Inequality got reversed because base is less than 1 here. Now if I cross multiply, so I will get 2 mod z plus 22 greater than or equal to mod z square minus 2 mod z plus 1. Take everything to the right hand side, so you will get mod z square minus 4 mod z minus 21 less than 0. And I think I can factorize it. Its factors are mod z minus 7 mod z plus 3. So this gives you mod z lies between minus 3 and 7. And we have equality sign here. So obviously maximum mod z can be 7 only. And minimum you will not write minus 3 because modulus cannot be negative. In case they ask minimum, minimum will be 0. Modulus cannot be negative. Let's solve this question. Simple telescopic sum based on inverse trigonometric function. So let's make it telescopic first. Sk is what? R varying from 1 to k. Tan inverse. If I divide both numerator and denominator with 2 raised to 2r plus 1 here, what I'm doing? I'm dividing both numerator and denominator with 2 raised to 2r plus 1. So I will get 1 here. And then I will get 3 by 2 raised to 2r plus 1 here. And here I will get 6 by 4 means 3 by 2 raised to r into half. This can be written like this. Now this is r varying from 1 to k. Now let's convert it in the form tan inverse x minus y over 1 plus xy. So I can write it as 1 plus 3 by 2 raised to r plus 1, 3 by 2 raised to r, the denominator. And numerator can be written as 3 by 2 raised to r plus 1 minus 3 by 2 raised to r. So now you can see that it is basically a formula tan inverse x minus y over 1 plus xy. So I can write it as tan inverse 3 by 2 raised to r plus 1 minus tan inverse 3 by 2 raised to r. And now it is telescopic. When you put r is varying from 1 to n, all the terms gets cancelled. Only 2 terms left. The last one, which is tan inverse 3 by 2 raised to n plus 1. And the first one, which is tan inverse 3 by 2 with minus sign. Now when n goes to, it was 1 to k, not 1 to n. So tan inverse 3 by 2 raised to k plus 1 here. And when k goes to infinity, so then this tan inverse infinity becomes pi by 2 minus tan inverse 3 by 2. And pi by 2 minus tan inverse x is cot inverse x. So it is cot inverse 3 by 2. D option should be the correct option here. 18th question. The number of elements in this set means you have to solve this equation and see how many values of x you are getting satisfying this equation. So the number of values of x which you are getting, real values, that will be the number of elements in this set. And we have mod x here, mod of x plus 4 here. So I have to take different cases. First case, when I'm taking the first case, when x is less than minus 4. So if x is less than minus 4, then what happens? See, your equation is for x less than minus 4, your equation is minus x minus 3. And x less than minus 4, the mod of x plus 4 will become negative of x plus 4. It is 6. So this becomes x plus 3, x plus 4 is equal to 6. This gives you a quadratic equation x square plus 7x and 12 minus 6 plus 6. It can be factorized x plus 1, x plus 6. So you are getting here minus 6 and minus 1. But out of these two, only minus 6 will be considered. Minus 1 will be rejected. Why minus 1 is rejected? Because you are considering the case x less than minus 4. So x should be less than minus 4 here. Minus 1 is not less than minus 4. So this will be rejected. Second case, if I take x between minus 4 and 0. So then I will get what? I will get, now x is still negative. So I will get minus x minus 3. But here I will get plus x plus 4. It is 6. So this will be x square plus 7x plus 18, 0. Minus taken common, yes. And you can see that the discriminant of this quadratic is negative. So you are not getting any real root here. No real root here. Now let's take the third case. If x is greater than or equal to 0. So then you will get x minus 3, x plus 4 is equal to 9. And this becomes x square minus x, in fact plus x, minus 12 minus 9 minus 20 is equal to 0. X square plus x and minus 2, yes. Oh, it was 6 on the right side, no? I have written 9 here. 6. So it will become what? It will become x square plus x and then minus 12 minus 6 minus 80. If I use quadratic formula here, so x will be minus b plus minus under root 73 b square minus 4ac by 2. But x is positive here, greater than or equal to 0. So only positive value will be considered. Negative value will be rejected. So basically you are getting only two solutions here. Which are the two solutions? One solution you are getting here minus 6 and one solution you are getting. So means this set will contain only two elements. Option C is the correct option here. D is the domain of this function. Then G is another function which is defined from D to R. Gx is this. And they are saying that the greatest the range of Gx is alpha to beta. So what will be integral part of log alpha with the base 3? So basically I need the smallest value of Gx on. But I need the smallest value of Gx. And for that I need the smallest value of x on. What will be the smallest value of x? So let's see here. Since we have sine inverse here, so this quantity log with the base 3x 6 plus 2 log x with the base 3 over minus 5x. This quantity must be lying between minus 1 and 1. This quantity must be lying between minus 1 and 1. And x is for sure positive here because you are taking log x with the base 3. So x is for sure positive. One more thing, we base the 3x, that should also be positive here. So if x is positive, of course 3x was positive, but base should not be 1. 3x should not be 1. One more thing, this whole quantity 6 plus 2 log x with the base 3 over minus 5x. This quantity should also be positive because we are taking log of this. So this one is also positive and x is already positive here. X is already positive here. So this denominator is negative. So if I cross multiply, inequality gets reversed. So 6 plus 2 log x with the base 3 is less than 0. So this gives you log x with the base 3 less than minus 6 by 2 minus 6 by 2 minus 3. So x is less than 3 raised to minus 3, 1 by 27. X is less than 1 by 27. So x is positive but less than 1 by 27. So from here I got that x is a positive number between 0 and 1 by 27. Now I have to solve this inequality also. Now x is between 0 and 1 by 27. So obviously this 3x is less than 1. Means base is less than 1. So when you remove the log, inequality gets reversed. So you will write 3x raised to minus 1, 1 by 3x. Inequality gets reversed. 6 plus 2 log x with the base 3 over minus 5x greater than or equal to 3x raised to 1, which is 3x. Now if I solve first two inequalities here, these two. So since x is positive here. So what I will get, I'm solving first two here. So I can write, see if I cross multiply here, these two, inequality will be reversed again. So I will write 5 by minus 5 by 3 less than or equal to 6 plus 2 log x with the base 3. Now if I solve this one, I will get minus 5 by 3 minus 6 less than or equal to 2 log x with the base 3. So what I am getting here, minus 23 by 6, yes, less than or equal to log x with the base 3. So this gives you x must be greater than or equal to 3 raised to minus 23 by 6. And I'm concerned with the smallest value of x only. I'm concerned with the smallest value of x only. So I can say that yes, x is, let me check, yes, 29. So just focus on it. So smallest value of x that I'm getting is 3 raised to minus 23 by 6. And for this smallest value of x, you will get a smallest value of alpha. You will get smallest value, means the smallest value of this function gx. So alpha is what? Alpha is basically x minus integral part of x, which is fractional. And see, this 3 raised to minus 23 by 6 is a number lying between 0 and 1. So integral part of 3 raised to minus 23 by 6 will be 0 only. So for this number, gx will be basically same as x. So ultimately alpha is nothing but 3 raised to minus 23 by 6. For this value, whatever value you are getting for gx, that is alpha, smallest value. Now alpha is this. Now I need log alpha with the base 3. So if I take log with the base 3 both sides, so it is minus 23 by 6. I need its integral part. So this number lies between minus 3 and minus 4. So its integral part is minus 4. Means option C should be the correct option. 20th question. You have to check which option is correct for unique solution, many solution, infinitely many solution like this. So first check the determinant formed by the coefficients D. So that is 1, 1, 1, 1, 2, 3, and 1 alpha 5. 1, 1, 1, 1, 2, 3, 1 alpha 5. If I expand this one, let's not waste the time. Let me check what value I will get here after expanding this determinant. So after expanding this determinant, you will get 6 minus 2 alpha. So this determinant is 6 minus 2 alpha. Obviously, it is 0 if alpha is 3. And in all other cases, it is not 0 if alpha is not 3. So some of the options I can eliminate right away. You see, if alpha is not 3, then I will get a unique solution. Alpha is not 3. So in the first option, alpha is not 3, alpha is minus 3, so I will get a unique solution. Means this is correct. And in all other options, alpha is 3. In all other options, alpha is 3. Now when alpha is 3, so then either you will get no solution or you will get infinitely many solutions depending upon D1, D2, D3. So let's check D1, D2, D3 now. D1, D2, D3, how will you check? So if I check here, they have written delta x, delta y, delta z. I'm saying D1, D2, D3. So you will see that for alpha is equal to 3. In fact, all the 4 determinants become 0. Means D1 will be what? In this one, replace 1, 1, 1 with 110 beta. So in fact, for beta is equal to 14, all the determinants become 0. They have given. So just check all the 4 determinants D1, D2, D3, D1, D2, D3. How will you check? See the first column 1, 1, 1 will be replaced with 6, 10 beta. So that will be D1. When second column 1, 2, 3 is replaced with 6, 10 beta, that will be D2. And when the third column 1 alpha 5 is replaced with 6, 10 beta, so that will be D3. So this comes to be 0 if beta is 14. Means for beta is equal to 14, you will get infinitely many solutions. So this option is also correct. For beta is equal to 14, you will get infinitely many solutions. Alpha 3, beta 14. So all four determinants will be 0. Alpha 3, beta not 14. So obviously you will get no solution. Here they have written unique solution. So this statement is false. System has no solution for alpha is equal to 3, beta is 24. Yes, when alpha is 3, d will be 0, but this d1, d2, d3 will be non-zero. So this one is also correct. So C option is your correct option. Means C option is not true. Let's check this value. So we have tan 9 degree here. 81 can be written as cot 9. 81 can be written as 90 minus 9. Then tan 27 degree here. 63 can be written as cot 27. 90 minus 63. Now I write sine over cos. Tan 9. Write each tan as sine over cos. So you will get 1 by sine 9 cos 9 here. And 1 by sine 27 cos 27 here. And if you multiply numerator and denominator with 2 in both, so it is 2 by sine 18 degree. And then 2 by sine 54 degree. 2 by sine 18 degree. 18 degree is root 5 minus 1 by 4. And 2 by sine 54 degree. 54 degree is cos 36 degree, which is root 5 plus 1 by 4. Now just solve this, you will get your. So if you solve this one, final value will be 4. Here we have to find the coefficient of x raised to 4 in this binomial expansion. So let's find general term first, tr plus 1. So it is 15 cr x raised to 4 whole raised to 15 minus r minus 1 by x cube raised to r. It is 15c4, 15cr. X raised to 4 raised to 15 minus r, so it becomes x raised to 60 minus 4r. Then minus 1 raised to r, x raised to 3r. So finally it is 15cr minus 1 raised to r, x raised to 60 minus 7r. I need what? I need coefficient of x raised to 18. So that means this quantity should become 18. So 60 minus 7r is 18 here. 60 minus 18, 42. So r will be 6 here. So just put r is equal to 6. You got your coefficient. The coefficient of x raised to 18. Put r is equal to 6 here. So 15c6 minus 1 raised to 6, which is 1. So 15c6 will be the correct answer. And you can easily calculate 15c6. So 15c6 will be 5005. Next. Fx is this integration. And we have to find the limit of this integration when n is approaching to infinity. So when n is approaching to infinity, what will be the limit of this? So first check pattern. Fx is this. What will be f square x, f cube x, like this. So if I check f square x first. F square x means f of fx. So replace x with fx, you will get fx 1 plus fx raised to n whole raised to 1 by n. This is f square x. Now if I put the value here, fx is what? Fx is x over 1 plus x raised to, so x over 1 plus x raised to n whole raised to 1 by n. 1 plus fx raised to n is what? Fx raised to n will be x raised to n over 1 plus x raised to n whole raised to 1 by n. Now if you solve it, you will get it as x over 1 plus 2x raised to n whole raised to 1 by n. So see, when you got f square x, this x becomes 2x here. Similarly, in f cube x, it will become 3 here. In f4x, it will become 4 here. So I can write fnx will be what? Fnx will be x over 1 plus n times x raised to n whole raised to 1. This is fnx. X over 1 plus n times x raised to n whole raised to 1 by n. Just see the pattern. In fact, if you are not sure, just check one more time. What will be f cube x? So f cube x you will get 3 here. So that means observing the pattern, I can say kfnx it will be n here. Now let's check the limit. Integration. So integration is what? 0 to 1 x raised to n minus 2 and then fnx. Fnx is x over 1 plus n x raised to n whole raised to 1 by n dx. So now you have to integrate this. Now you can see that this numerator x raised to n minus 1 is basically the derivative of this x raised to n. So if I substitute this 1 plus n x raised to n as t complete. So if I substitute this 1 plus n x raised to n as t, or I can substitute 1 plus n x raised to n as t raised to n also. That will be better actually, because in that case denominator will simply become t. So if I substitute 1 plus n x raised to n as t raised to n and differentiate it, so I will get here n square x raised to n minus 1 dx n times t raised to n minus 1 dt. Now substitute here. So this integration is what? See, when x is 0, t will be 1. And when x is 1, so t will be what? T will be 1 plus n raised to 1 by n. 1 plus n raised to 1 by n. Let me write once again. It is 0 to, when x is 0, t is 1. When x is 1, t will be 1 plus n raised to 1 by n. Now x raised to n minus 1 dx from here. X raised to n minus 1 dx will become what? It will become 1 by n t raised to n minus 1 dt. You can check. X raised to n minus 1 dx 1 by n t, and denominator becomes t. So now I'm getting what? I'm getting 1 by n t raised to n minus 2, and t raised to n minus 2 integration will be t raised to n minus 1 over n minus 1. Lower limit 1, upper limit 1 plus n raised to 1 by n. Let me check once again. X raised to n minus 1 dx. X raised to n minus 1 dx is what? 1 by n t raised to n minus 1 dt from here. So 1 by n, t raised to n minus 1 dt, and then by t. Now this is what? This is 1 by n minus 1. Put the upper limit. So you got 1 plus n raised to n minus 1 by n minus 1. Right? Now I have to take this limit when n approaches to infinity. When n approaches to infinity, then what will be this limit? So see, I can write it as 1 plus n raised to n minus 1 by n. 1 plus n raised to 1 minus 1 by n. It is what? When n goes to infinity, base is going to infinity, power is going to 1 minus 1 by n, power is going to 0. Okay. So anyhow, I can write like this. 1 minus 1 by n. So 1 plus n raised to 1 by n, when n goes to infinity, that will become e. Let me check the limit. 1 plus n raised to 1 by n when n goes to infinity. So this limit should be e raised to 1. Yes, this limit should be e. So 1 plus n raised to 1 by n, but we have n minus 1 also here. So what I can do here? Okay, let's replace n with 1 by x and n with 1 by z and see what happens. Or you can say it is a infinity raised to 0 form. No? The base is infinity. Here. Base is infinity. Power is what? Power is 1. In fact, maybe I'm doing some error here. Let me check once again. 1 plus n x n. I think everything is correct till here. Let me check if I've done some error, whether I'm getting final thing same or not. Final thing I'm getting, yes, I'm getting same. 1 over n minus 1. 1 plus n raised to n minus 1 by n minus 1. This is what I'm getting here. 1 plus n raised to, yes, so there, this is what I'm getting. So now only thing remains, okay, let's find this limit. So let's find this limit. What I will do, okay, let's substitute n is equal to, let's substitute n is equal to 1 by t here. N is substituted as 1 by t. So when n goes to infinity, t goes to 0. So t will be approaching to 0 here. So let's find this limit. This limit is what? 1 plus 1 by t. It is 1 minus 1 by n, means 1 minus t minus 1. And in the denominator, I will have 1 by t, 1 by t minus 1. T is approaching to 0. Everywhere n is replaced with 1 by t, so 1 plus 1 by t. Here 1 minus 1 by n, so 1 minus t minus 1, and denominator is 1 by t, 1 by t. So now it is what? It is limit t approaching to 0. 1 plus 1 by t raised to 1 minus t minus 1, and denominator will be what? Denominator will be 1 minus t. 1 minus t only here. And t square will go up. T square will go up. Now this is what? When t goes to 0, base is 1, power is 1. So this is straight away 0, I think. Yes. See, when t goes to 0, So this base is 1 here, power is 1, so it is 0. In fact, straight away you can say this limit is 0. Let me check. When you put t 0, so this is, oh sorry, it is 1 by t. I thought t. So I have to set the formula here. So it is infinity actually here. Infinity raised to, so can I use binomial 1 plus nx because t is very close to 0. So I can write t is infinity, in fact 1 by t we have 1 plus 1 by t. So I can write it as, see the second one I have no issue. The second one can be written like this. The only issue is in the first one. I can write t square 1 plus 1 by t raised to 1 minus t by 1 minus t. This is the first one. And in the second one, I'm getting t square over 1 minus t. So this second one basically becomes 0. Here I have no issue. The only problem I have here, t square 1 plus 1 by t raised to 1. And in fact, in denominator also I don't have any issue because this denominator will become 1. So I have to get this limit only, t square into 1 plus 1 by t raised to 1 minus t. So what I will do in this one, let me write like this. See, I can erase this one because this one is 1, this one is 0, this one is 1, this one is 0. So just focus on this limit. What is this? Limit t approaching to 0. T square 1 plus 1 by t raised to 1 minus t. Let's focus on this limit on. What will be this limit? Now when t is approaching to 0, so this is approaching to 0, this is approaching to infinity. So let's make it infinity by infinity. I can write it as limit t approaching to 0, t square and I can write this one as e raised to 1 minus t log 1 plus t. E raised to t. Our final answer is 0 only. Yes, so that means this limit should also become 0. So e raised to 1 minus t, you see a raised to x can be written as e raised to x log a. So I can write it as e raised to 1 minus t log 1 plus t. And then we have t square here. And what? Then I can write, this is what, when t goes to 0, and this is e raised to, t goes to 0. So that means e raised to log 1 is 0 here. Okay, I got it. 1 plus 1 by t raised to t. That will be e, and 1 plus 1 by t. The numerator t is 0, so that will be infinity. Let me write like this. I can write like this, t over t square 1 plus 1 by t raised to t and then 1 plus 1 by t, like this. Now limit t approaching to 0. Let's multiply t inside. So I got t plus 1 and 1 plus 1 by t raised to t. And this is standard formula. 1 plus 1 by x raised to x, when x goes to infinity, it becomes e. This limit will be, this is standard formula, 1 plus 1 by x raised to x. When x goes to 0, this limit will be e. 1 plus 1 by x raised to, this is 1 plus 1 by t raised to t, this is e. And in the numerator, t is 0. T is 0, so obviously it will become 0 into 1 by e, which is 0. So yes, it is 0. Let's see the last question. We have not last question, it is second last question. 3 vectors a, b and c such that c is coplanar with a and b, a dot c, and c is perpendicular to a also. C is coplanar with a and b, and b is perpendicular to c. So that means the vector c is coplanar with a and b, and one more information is given that c is perpendicular to b. So you can take c vector like this, lambda times a cross b cross b, because this vector is always coplanar with a and b and perpendicular to b. Whenever you are writing a vector like this, a cross b cross c, this vector is coplanar with a and b and perpendicular to c. So that's why I'm writing like this. C will be lambda times a cross b cross b. And a cross b I can find easily. And b, so in fact I can write, let's use vector triple product formula here. So I can write it as lambda times a dot b multiplied by b minus b dot b multiplied by a dot b multiplied by b minus b dot b multiplied by b. Now what is a dot b? A dot b you can easily find here, minus 1 into 2, which is, I'm finding a dot b. So let me write here a dot b. A dot b, if you find a dot b, dot product of these two, this one and this one. So a dot b is what? Minus 2 plus 1. Minus 1 into minus 2, minus 2 plus 1. So it is minus 1. And b dot b is what? B dot b is 4 plus 1, 5. So I got here a dot b, which is minus, and b is 2i plus k. B dot b is 5. A is minus I plus j plus k. So now you got this vector lambda times 5i minus 2i, which is 3i, minus 5j, minus 5k minus k, minus 6k. Now only missing thing is lambda here. So how will you get lambda? So see, a dot c is given as 7. So let's find a dot c. A dot c will be what? Take the dot product of a with c. So that is lambda times minus 3 minus 5 minus 6, and it is given as 7. So this gives you lambda is equal to 6 and 5, 1 minus 1 by 2. So I got vector c. Vector c is what? Minus 1 by 2, 3i minus 5j minus 6k. And no problem is easy. Just find a plus b plus c vector because all three vectors are known, a known, b known, c known, and take its modulus. So after that it is just easy, find a plus b plus c and then take its mod. Okay. C I got minus half 3i minus 5j plus minus 6k. So same C they got here, half times minus 3i plus 5j plus 6k, and then find a plus b plus c and its modulus, which is very easy. Final answer will be 75. Last question, they are saying a die with n faces numbered 1, 2, 3 and written on them is rolled repeatedly until a number less than n appears. If the mean of the number of tosses required is n by 9, so what is n here? So basically this is probability distribution, and then you have to find mean. So here random variable x is what? Number of tosses required. Number of tosses required. So x can be 1, maybe in the first toss itself. In the first toss itself, you got a number less than n. Means you will stop as soon as you got a number less than n. So maybe in the first toss itself, you got a number less than 1. Maybe you need 2 tosses, you need 3 tosses, you need 4 tosses, and this game can go up to infinity. This game can go up to infinity. So what will be probability of x is equal to r? X is equal to r means कि you got a number less than n in rth toss. What is this? Probability of getting a number n, number less than n in rth toss. So that means कि in the first r minus 1 tosses, you not. And what is the probability of getting a number less than n? See, probability of getting a number less than n, probability of getting a number less than n, because we have n faces numbered 1 to n. The probability of getting a number less than n is n minus 1 by n, and probability of getting a number not less than n means equal to n. Probability of getting number not less than n is basically 1 by n. So when you are getting less than n in rth toss, is that means कि in the first r minus 1 tosses, you have got a number not less than n, means you have got n. So that is 1 by n. And 1 by n how many times? R minus 1 times. And in the rth toss, you got a number less than n. So that is n minus 1 by n. So this is the probability of getting a number less than n in rth toss. Now what you need now? You need its mean. Mean is given 9 by 9. Mean is given n by 9 in fact. So how you write mean? Mean will be x multiplied by its probability. X multiplied with its probability means r multiplied by probability of x is equal to r. R is varying from 1 to infinity. This is n by 9. So this is r varying from 1 to infinity. R into 1 by n raised to r minus 1, n minus 1 by n is n by 9. R into 1 by n raised to r minus 1, n minus 1 by n into n by 9. See, this n minus 1 by 9 is a constant quantity. You can take it outside. So you got n minus 1 by n outside. Sigma r varying from 1 to infinity. R into 1 by n raised to r minus 1. This is n by 9. And now if you expand r varying from 1 to infinity here, so you will get an AGP here. It is basically, for r is equal to 1, it is 1, then 2 into 1 by n, then 3 into 1 by n square, then 4 into 1 by n cube. So this is an AGP. And you know how to find the sum of AGP. Just find the sum of this AGP and put here, you will get your answer. So, or you can use actually binomial also. Actually, this AGP after expansion will become 1 plus 2 by n, 1 by n, 3, 1 by n whole square like this. So using binomial expansion, it is nothing but 1 minus 1 by n raised to minus 2. In case you are not able to use binomial, you can use AGP formula. It's your choice. You can use AGP or you can use binomial. So if you expand here, let me show you. If you expand here, so you are getting n minus 1 by n. For r is equal to 1, it is 1. For r is equal to 2, it is 2 into 1 by n. For r is equal to 3, it is 3 into 1 by n square. Then 4 into 1 by n cube up to infinity. And as I told you, this is an AGP. Use AGP formula or use this binomial expansion. If you expand this 1 minus 1 by n raised to minus 2, you will get this. But in case you are not able to get this binomial expansion, just use AGP formula. So you will get what? N minus 1 by n here. N minus 1 by n. Then you will get n square over n minus 1 whole square, n by 9. N and n cancel here. This n and n also cancel. N minus 1 also cancel. So ultimately you are getting n minus 1 is equal to 9. So n should be equal to 10. So n is finally 10 here. Right? Chalo, let's wrap up the session, guys. Bye bye. Take care. Bye everyone. God bless you all.